I seen what you've done to this excellent effigy of one of my forefathers.
That's Homer under there.
That's one of my forefathers under there.
Just confirming.
Check. Testing, 1, 2, 3.
Giovanni, did you get a haircut?
Yeah. Not so much, but yeah.
A trim, as the ladies call it,
Yeah,
right?
that's it.
Very professional.
All right, the YouTube seems to be rolling.
Okay.
Did you guys check the audio? I'm not sure if it's working.
Yeah, it's sounding pretty good. I hear
Okay.
the echo of myself.
I'm dropping out then.
Bye, Max. Well, ladies and gentlemen, I hope everybody had a great weekend. Today, we're bringing you the continuation of the OpenSIPS Summit 2020 distributed. Today and tomorrow, we'll be holding our workshops. Each one of these is going to be about an hour long. We've invited everybody into the meeting channel as well if you want to participate, be a little bit more real time with some of the questions and interaction, which we had lots of last week. I do have to say, it was an amazing week of presentations and amazing community bonds. Like, I feel like our family now, I knew it was global, but now it's like really all over the place. It's everywhere. And we've met and accepted a bunch of new brothers and sisters on this amazing OpenSIPS journey that we're all on. So, like I said, in continuation, today we're going to have the workshops. They're going to be about an hour long. Anybody in the channel, the rules are, let's just keep the chit chat and questions to the end. Let the presenter try to get through their presentation. If they ask at any given time, if people have questions, feel free at that point to maybe pop up and ask a few. But for the most part, let them get their hour in there because they have some really cool stuff to show everybody. Today, my wingman's going to be Liviu. I'm sure everyone remembers who he was. This is both the creator and maintainer of the Live AI. It's our amazing picking tool. We've actually gotten some calls from some lotteries. And as you can see on the expression of Liviu's face, we're really excited for the next rendition of this to come out. I hear that there might be some possibility that before this thing is said and done this week, yet another raffle might occur. So I'm just throwing it out there. I don't have anything verified. This is all grapevine. So without much further ado, I'm going to be handing the stage over to Mr. Lorenzo Mangani. He is the man over at Homer. He's going to be talking to us and showing us some pretty cool stuff with Homer and OpenSIPS today. Lorenzo, are you here?
Yes, I am. Thank you, Alex. And thanks everyone for sticking around into this beginning of the new week. So indeed, today this little workshop is going to be about what I know about OpenSIPS, HEP, and Homer, and how to put the pieces together. Something that I've just had to redo myself over the last week. Quite interesting journey coming from previous version. So just sharing the bits and pieces, and everything contains also a few workable examples, recipes, configs that you can go and either take a look at while we go through them or fetch later. As usual, we're all good at stuff until we do it live. So this might go sideways. Let's see, how well it goes. It's pretty fresh. I don't know how long it's going to take or how many people are actually going to try it. But I'm going to pretend on the other side there's at least a couple of guys trying to run this. So I'm going to go at that speed if I can. Quick one. If you're here, you probably already know what Homer is. Carrier-grade capture system for packets, events, and a bunch of other stuff. Long story short, it's a time machine where we're going to try to collect, all of the vitals for our platform in order to go and investigate it either in real time or looking back in time for things that have happened. Homer is the type of tool that you really only use when there's a problem. So it's not something that you normally would say, hey, let me go look at what's up in Homer. That's unlikely, but it is the tool that we hope people bring up first when they have a problem. The secret of the platform, like probably most of you know, but it's worth saying, is the HEP encapsulation protocol. This is the glue. Without this, Homer would make little sense, or it would just be another project out there. So the HEP encapsulation makes it, live on. So the fact that we have HEP in OpenSIPS and all of the other platforms make it possible and viable for people to actually give it a try. And indeed, today we're talking about OpenSIPS and how to, latch OpenSIPS and Homer together. Since the integration level of HEP in OpenSIPS, especially the latest version, is magic, I called it, OpenSIPS for HEP magicians, because some of these tricks might look simple, but they can have a really spectacular effect when they're all assembled together. So the idea for this hour is to give you some examples as of how to bootstrap Homer 7 and an OpenSIPS 3.1 instance using Docker. You can, of course, use the configs and whatever else to do it outside of Docker if you wish, but this was a way for it to work for sure. We're going to configure OpenSIPS. So mentioning what are the key parameters to make it happen. So to make so that OpenSIPS starts sending HEP packets to Homer for SIP, which is, same old story as always. And this time also with Xlog, REST events, and a bunch of other stuff. At the same time, we're also going to configure RTP engine or RTP proxy either for sending RTCP HEP statistics. The idea is that we get a little, simple but full Homer, where we can look at the signaling, we can look at some events, they could be any, and baseline of statistics. At the same time, we're going to see a few things about searching Homer and setting up a few things. Depending on the time, I'm going to save this for the end. So to complete it, if you want to follow the examples, you need, of course, a Linux system, a VM, or whatever running Docker and Docker Compose, a couple of SIP accounts if you want to actually try it out, and you're going to need to know your IPs and stuff in order to backfill them in the configurations where needed. Also, something to drink wouldn't be bad. I'll do the same. If you have any questions, type in the chat. I'm not going to be looking at it the whole time, but I'll definitely see it here and there. So if you have anything that's important, interrupt me. Otherwise, just type it down and I'll try to get to it. As some of you may know already, Homer is not really like an application, but rather it's a set of dynamic components that come together. It's an orchestration of tools that talk to each other or query write to each other, mostly using the HEP protocol, but not only. So on one side, just to recap, we have what we call capture agents. This could be anything. It could be the HEP agent inside of OpenSIPS. It could be one of our agents such as Amplify. It could be anything else that can generate HEP data. Janus as well now. The capture server is the receiving part, where this used to be OpenSIPS back in the day. Nowadays, it's a standalone Go application that's receiving HEP packets, dissecting them, writing them to database, calculating and writing time series, and a bunch of other stuff. And on the opposite side, we have the UI and the API that simply connect to the same data sources. And this is what the users will mostly see. It's all in separate components, meaning that the database, the time series database, the capture server, the UI, they can all sit in different places. It's not a monolith, so that it's easy to scale it and make it redundant. A bunch of options, but again, they're made for flexibility. So it's always worth asking why or which one is best, maybe in our mailing list and so on, where we have a bunch of people that actually use it on a daily basis. So today we're going to install everything that you see on screen. So we're going to run a container with 106 applications. I'm just kidding. Today, we're going to run an OpenSIPS and RTP engine-centric setup versus a vanilla Homer instance, so the one that you would find if you start it up on your own. And we're going to connect it to either InfluxDB or Prometheus. I'll have examples for both, and Postgres for data. Optionally, also Loki for logs, but I don't know if we'll make it that far. So again, the logic is that our OpenSIPS and RTP engine both support HEP, so we can use their native features to basically send us everything we want without messing with it. And this is going to include everything that's encrypted. So it doesn't matter if, in this case, you have TLS and everything else in place as you should. Homer and HEP are going to continue working exactly as designed, and that's the beauty of having them natively integrated rather than passively obtained with an agent. If you want to use Docker, this is your screenshot. So this is the versions that I'm using locally. They're not the latest, but anything later than this should work fine. If you don't have them, you want to install it, doesn't really take that long, and I have a few links there for you. The other thing that I mentioned you should know is your public and private IP. If you plan on following the guide or running the Docker containers, this is basically the only two things that you're going to have to configure in the Docker Compose files, just to tell the system how to be reached for some of the items, mostly for OpenSIPS, I guess. Installing Homer. So this is quite the first thing that we'll do. So we want to have a collector up and running, so that everything that we'll do afterwards can be validated, verified, and we can check it out together. So if you want to do it with the Docker containers, you just copy paste one of those two blocks. If you want to do it with InfluxDB, is the first one. If you like Prometheus better, is the second. They come with a slightly different setup, so there might be some inaccuracies here and there in the presentation, but you'll figure it out. It's just different parts and different services. The Prometheus one comes with Grafana. The InfluxDB one, it relies on its own stack, so it comes with chronograph, capacitor, and all that jazz. If once you start it up, of course, it takes a few minutes, but when it's done, you should see something like this in your Docker PS. So you should see a bunch of containers. If you want to go through them, the first one is Amplify server. So what we call the capture server. This is the receiving part. We have the web application, which is the UI, and we have basically the rest is all database related. So Postgres, which is where we store, packets and HEP stuff. InfluxDB, which is where we store the time series that we can generate while we crunch all the traffic, and the rest is basically accessories. So telegraph, chronograph, capacitor are all part of the tick stack, and they're used for looking after data, inserting data in case of telegraph, and capacitor for designing alerts. If it looks anything closer to the above, you're good to go, and your system should be up and running. So if you browse to the public IP of your instance, you should end up into your Homer login. If you see this Homer login, basically you should be good to go. The default credentials are on screen, so you can give that a try, and you should end up in an empty, sad dashboard that shows nothing. But it's a good sign that your system is up and running and most likely ready to receive packets and crunch some data. How do we make sure? There's a tool for that. So HEPGen is one of our Node.js tools that have actually been around for a long, long time. And this is the way we test things with either in CI integrations or even just when we baptize a new system. First thing that we do is we run one or a few of these HEPGen scenarios. You can do the same from any machine, actually, because if you set up everything right on the public IP of your server, as well as the private, of course, you should be listening on port 9060 for HEP traffic. So you can use that port, which is the default, and run HEPGen. This is basically like CP, but for HEP. It's something that can take a scenario and change a few parameters, like generates a new call ID or randomizes from and to users. It just generates a random similar call that can be used to validate the system. You let it run for a couple of minutes because it's a real-time kind of emulator, so it waits between messages and so on. And you should end up with something like this. So if you go back to your little set empty UI and you click search again, in this case, we're looking at the last 30 minutes. So make sure you always select a range from the top. 30 minutes should be enough. We just started 15 minutes ago, if anybody made it. This is what you should see. So something from user hepgen with random IPs, random usernames and whatever. And this validates that your setup is basically working and ready for the real thing, the real traffic that might be next. If you click the call ID, so when we were here in the results, you see there's a session ID column, which is clickable. Once you click that column, you get the session details, and you should see a few tabs. If everything worked, you should see 5 tabs. So the first one is messages, where it's like a Wireshark view of the messages that were captured, as well as the events or anything else that made it into the system. The second one is the flow version of the same, so the same data displayed in a horizontal flow, and here you will see different colors for different sessions and so on. I'm going to show you a few examples later down. And then QoS tab, which shows us the collected RTCP statistics, if we have received any, and this is going to be divided in by stream, so source, IP port, destination IP port, and unique source for the streams will be displayed separately, so we can see if a specific stream attached to a specific session was, giving us issues. And then logs, which is basically everything else, and much of what we're going to see today actually has to do with this, because OpenSIPS has now the capabilities to just insert data related to a session in real time while it's mirroring. So if you're doing that, since we're at it, you should browse to the top menu of Homer, settings and aliases, and you should define one for the IPs of your system. We have an example here on the screen. If you want to take a minute to take a look at it, we have a few fields. Alias name, this is what's going to be displayed, or how we're going to call this element. The second one is the IP address. This might be your public IP address, your private one, or both. If you use 2 different IPs with the same alias, you're basically telling Homer that this is a back-to-back user agent, and they should be merged whenever required by the UI. The port field is the one where we can decide if we want to map to a specific port. Let's say on the same IP, you're running multiple services, you want to give them different names, you can. If you want to match them all, so anything that comes or goes to a specific IP, you can use 0, just like in this example, which means match everything. The next one is bit mask, so you can use the same logic to define a subnet rather than a specific or single IP. So if you want to say this is my, this subnet is my peering with operator X or carrier Z, you can do so. And the last one is a capture ID, which is an override for the aliases. Status decides if this is enabled or disabled. And once you save it, it works as in the example here on the right. Oops, went too far. Example on the right, so you're still going to see the IP, and on top of it, you're going to see whichever alias you had defined. If multiple IPs match the same alias, you will see them all. So this makes it pretty easy to look at, complex back-to-back user agent flows and so on. So up until this point, you should, by following this structure, you should have spin up a capture core for Homer. So capture server with its database, time series database up and running, and working HEP socket that we have just tested with hepgen. Just before we walk forward, does anybody have any questions? Sounds like you don't, so let's get real. So what we want to do next is actually send these things some real data. Before we do that, let's talk about how. The secret, of course, is within OpenSIPS itself. So the old OpenSIPS, which was still, very full-fledged in terms of app support, was only able to send or mirror SIP packets back to the platform. So just the messages going in and out. The new versions go above and beyond, and they make it possible basically to send everything that's happening within the platform or that the user wants within the same stream. So at the same time that you're mirroring your invites, methods, and responses, you can also mirror specific logs that you think might be interesting. So if your config makes a decision, you can attach a log, and this log will be presented as part of the troubleshooting. So the user will see before the response what the decision was internally to the car, which is vital to understanding why things are happening, or if this was something that the system did intentionally, or a real fault, or whichever else. So now we can set the known SIP events as they're documented. So we have SIP triggering events, so something that will have something to do with the modules, with the signaling traffic that's going in from any type of socket. And I'm forgetting how, yeah, they're called sockets now, 3.1. I need to remember. And this will be able to trigger HAP mirroring. Well, we can do also things the same way with REST queries, xlog messages, and MI commands, which quite frankly, I haven't tried yet, but it should be pretty easy if you're making use of them. So the schema on the right tells you a little bit about the magic within. So we will generate actually different type of events that glue to each other by virtue of correlation IDs. The correlation ID is typically the root call ID. So the first event that started, let's say, the mirroring session. And this can be propagated to other objects that we want to be related to this. Correlation can also be cascading. So A can find B, and B can find C and D. So it's a cascading process that happens actually inside of Homer. So as long as things are tagged and they have some IDs in common, they just show up. So if you haven't already, it's time to spin up an OpenSIPS 3.1 instance to try out the commands and or to validate those that you already have. For those that don't have it, or they just want to bring up a demo, I have this little Docker OpenSIPS app client container, which is actually OpenSIPS and RTP engine configured just as an insecure relay. So something that will just take and proxy to the original destination. So an outbound proxy. Not really transparent, actually. I left some little things in there to be found, but that's what Homer is for. So if you spin up this container, basically on 5060 on the same IP, unless you change it in the Docker compose file, you will find the OpenSIPS running and ready to receive data. The idea is that, well, I was jumping ahead of myself. How's this configuration made? Or actually, do you want me to run it live? Can copy paste from presentation, blah, blah, blah. I'm reading the chat. Yes, by the way, I'll make the presentation public so that you can actually copy paste everything out of it right after. And all of this is copy paste from our wiki or repositories. Actually, I should have had links for that. But we'll make it there quick. What I can do is actually run it. So this is on our Docker. So the first part is going to be bringing up the stack, just like I mentioned before. Check this tab. So containers that you have seen before. On our web app, Amplify server, everything should be up and running. And it is. Let's see if we can reach it. Port 9080 of the IP we're running. And there we go. Here we have our little empty instance with nothing inside. Now, let's do run. Oops. Where did I put it? OpenSIPS Docker. Here we go. So this time we're going to bring up this insecure OpenSIPS that we were talking about. So Docker compose up -d is going to pull this.
Lorenzo, sorry to interrupt you.
Go for it.
Just try to pull and got access denied for UXIP Docker OpenSIPS 3 HEP client. It says depository does not exist or may require Docker login denied.
Are you taking it from the repository that I
yes.
linked before? Okay, I'll
Just-
check that right after. It should be.
No, just for your info, you can continue.
No, thank you. No. This is exactly what we need. It's interactive, so
Okay.
I appreciate it a lot. So, is it running? Yes, it is. So we have our little OpenSIPs running and ready to get some traffic. Let's see if it works. I'm going to dial some random number. It's going to be just a default free switch IVR. Let it run for 10-15 seconds and hang up. And let's switch back to Homer. We're in the last 5 minutes. Click search again. Oh, we already have a scanner working with us. But there we go. This is my call. So I just dialed 5,000. And this is the session that came from this synthetic OpenSIPs. So if you're running it, you should be seeing something like this. So here are the tabs that we were talking about earlier. So messages where we can see everything that came in. And here you can already see some of the magic. So next to an invite, we have a log. This log was generated by OpenSIPs. So it's kind of OpenSIPs talking to itself or writing an X log. In this case, there you go. It's a X log entry that tells me that I'm letting something pass through. We have a bunch of those, and then we go back to the session. If this bothers the viewer, they can be filtered out. So I can remove log entries. I can make it complex or simple the way I want it. So depending on the type of investigation you're doing, you can disable it. As you can see, we also have RTCP events now in the timeline. So I can actually tell when things are starting to exchange media between them. There we go. It's actually a bunch of them. As you know, these can be very, very spammy, so work with it wisely. But these are the events that are being sent back and forth. And we can see them in the QoS tab, which actually shows me that this call had at least 3 legs reported for by the RTP proxy. And I can go ahead and exclude them or select them just to choose if I want to see only one, for instance. If I want to focus on this leg, there we go. I have my various measurements. I can look at the MOS, which is the default view, but I could also tune into the packet size, for instance, for one or more of them if I want to compare the legs. So you can look at the RTCP reports, let's say, from a few different angles. Same time, all of the logs that we have received are right here. So this is the selective, let's say, log that OpenSIPs has generated. This is just some random stuff that I was punching into this default. Of course, your X logs and REST lookups and MI comments are going to make sense for something. Mine definitely don't. But it's just to prove the point. So how did we do it? So let's go back here. So configuring, go back. Configuring OpenSIPs to use app is actually quite simple if you read the docs. And that's, I would stress on that part, read the docs and the right docs because it's all in there. It's just, quite complex maybe at the beginning, but not so much, I think, at the end. So leave you here, correct me if I go off track. But the first thing to notice is that in 3.1, what was SIPTrace is now Tracer. So there's a few semantic differences and naming differences, but for the rest, it works exactly the same. So the first step, as far as I know, at least, is to define, to load up the proto-HEP module and configure it. For the HEP ID, we define this HID, which is the basically identifier of the Homer instance that we're going to communicate with. So this 127.0.0.1 will be actually the IP or of your Homer instance. And port 9060 by default, transport UDP by default, it could be TCP, and version 3, this is mandatory to get all the nice features that we have. The second one is to tell Tracer that it should use it. So once we loaded the Tracer module, we give it, you basically pass it this TID with pointing at the HEP HID that we have just configured above. And this makes most of the magic happen. The second part is defining a route, the 2-Homer route, which is basically going to decide what type of tracing we're going to allow for different scenarios. So in this case, in the example, we can see that once we have determined if something is a dialogue or a transaction, we can decide to send them different types of logs. So for the first case, in the dialogue, we can enable SIP mirroring, Xlog, and REST variable propagation. I don't know how to say it, but you can take responses from the REST module and use them or log them back as HEP replies. And for transactions, we have selected SIP and Xlog only. So you can make your own recipes. I think we also have options for single messages and other stuff that I didn't include for space.
Yep, that is correct. And your affirmation regarding the translation between SIP trace and tracer, it's correct as well. We've changed that in OpenSIPS 3.1, right?
I've studied all night.
Thank you.
So that was the gist of it. So once you have this in place, it's not really much to be done other than start using it. And those are two examples from the documentation, which should work just fine. So when the features are enabled, the magic should happen. And for sure it does, because the Xlog, we have seen it works even just with the default and the dummy scenario that I spin up here. So you will see whatever happens here directly in the logs. Again, the magic is the correlation ID. So behind the scenes, OpenSIPS is being super smart, and it knows that this message belongs inside of a dialog, a transaction. It takes the ID, and it kindly uses it as a correlation header so that Homer can piece them together later. So basically, OpenSIPS is doing everything, and we just match two IDs that are the same. Well, we do it in a smart way. Any questions on this part, which might be maybe, you know, the most OpenSIPS related one from anybody in the room? Mind, this is straight off the documentation, so you don't depend on these slides. This is on the module, let's say, documentation. But again, the three parts that really matter, again, let's stress it again, ProtoHep and configuring an endpoint, associating tracer with ProtoHep, deciding what features tracer is going to use for various transaction types, and then use it. Keep in mind, the SIP part is done for you, so you have to do nothing there. All of the messages involved will be automatically sent, as we have seen here in the UI. If there are no questions, we move on. How do we do the rest of the magic? So as you, of course, know and do on a daily basis, in most deployments, OpenSIPS will be attached to either RTP engine or RTP proxy if you're dealing with media. And luckily, both of them support HEP just the same. So same logic. How do we get the RTCP statistics? We don't. They just volunteer them to us by virtue of the HEP integration. So we don't have to sniff anything. We don't have to hack anything. We don't depend on secondary agents of any type. It's all built in. In RTP engine, just 3 parameters that you have to configure, either in the command line or as variables. The Homer one, which actually takes the IPM port for your HEP server. In this case, public IP 9060 of the setup you're running on. Homer protocol is going to be UDP in most cases. And Homer ID, which we haven't mentioned before. This is how you can tell sources apart. Let's say that you have actually 10 RTP engines running. How do you tell them apart when you get statistics? Is by giving each a unique Homer ID. This way, you can go and either in a search or in the time series that we can generate, and you can say, okay, show me only the statistics for ID 9123. And you're only looking at your New York RTP engine or whatever. In RTP proxy, similar thing. It's called RTCP HEP module. Can be loaded and has exactly the same parameters. So public IP, port, protocol type, and capture ID, which is exactly the same thing. So just with those few lines and a little restart, you're good to go. Keep in mind, these things can generate a whole lot of data. So they can get pretty intense. The database is smart and it handles them well, but you might see a lot of statistics, and quite frankly, a lot of RTCP is garbage. So you should start and filter as you go. When you find streams or types of streams that make sense or directions that don't, you should make decisions to include them, exclude them, or get our consultancy and we'll tell you what to do. So to validate, of course, that we have everything up and running, if you use the Docker container, you would just run a Docker PS again and see if it's up and running, and you can go ahead with the same example. If you want to try it out, and again, if you're running just a vanilla dump setup to play with this and act with it, you can just use this instance as an outbound proxy for an existing account. I promise it doesn't send me anything. Yeah, it just hoops through it, and it basically uses all of the above to sniff. So we're a little bit of a proxy man in the middle just for HEP purposes in this example. So everything that you send is going to go through OpenSIPS. OpenSIPS is going to send it to Homer, and RTP engine or RTP proxy are going to be doing the same. You make a test call, use it as a proxy outbound parameter. Again, you can do this with your own setup, of course, just for sake of those that never tried it before and just want to see it on screen, because seeing is believing. And it should work. You wait a little bit, you say a few things, make them last, I don't know, 10, 15 seconds if you want to see also the media part, because if you make very short calls, it's going to be next to nothing in terms of being meaningful. And just like I did, you should get back some results when you refresh the screen. Keep in mind, Homer has a bunch of parameters, and I'll show you some of them afterwards, or maybe somebody else from my team wants to do so. But you should see the results. If you click the session, you should see the pop-up with the messages. You should see the logs that you have configured. You should see the statistics that tell you a calculated MOS, which is delta of packet loss, jitter, round trip time, calculated based on the RTCP reports. Our backend does this, so we get raw RTCP data, and then we aggregate it, let's say, in terms of both directions, so that we can get something meaningful out of it. But calling RTCP meaningful per se is kind of a weird statement. It's not. If you made it this far, well done. You've just set up a full Homer system, which is capable now of taking other traffic. So you can go ahead and you can enable HEP on all of your other equipment. If you have asterisk, free switch, all of your proxies, or if you're going to use Janus in the next workshop, keep in mind that this is all compatible with it. So you can just run an additional entry point, and if there's enough interest, we can just take a look at it, because it looks like I went faster than I thought. And we can spin up an entry point for JSON events, which are the type of events that are generated by Janus, but also media soups and other platforms that we use to backfill. Instead of signaling, we can use event streams and extract elements from them. Now, while Homer is going after all of these messages and indexing them and extracting stuff, it also, of course, counts everything. And everything is turned into time series that we send by default through a Prometheus endpoint. So there's a metric endpoint that can be fetched by anything. That's why Telegraph is on board. It actually fetches it and gives the user the ability to switch them between different platforms. So we can send a little bit of them to InfluxDB, a little bit of them to an actual Prometheus, some of them to an Elasticsearch, and so on and so forth. So what we really want is to give our people flexibility, because these decisions change. Whatever you're going to choose the first time that you deploy Homer, you're going to change your mind after a while. When you start using it, when you start learning what matters, what doesn't, you're going to be considering different options, different routes for stuff. And what really matters is not having a lock-in, right? So always having an easy way out or an easy way to prototype something is really what we want to have. So both in terms of inbound, so making HEP open, allowing you to write custom plugins and stuff like that is key to what we want to do with the platform. And on the other side, letting people write this data wherever they want. So by default, again, the options that you find there will be compatible with InfluxDB, with Prometheus, and Timescale DB, which is Postgres based, and it's pretty awesome. Maybe for this one, we have a little less support, but still, it's fully working. So if anybody's hacking with that, I would highly suggest to join in and help us perfect it. I could jump into this if it's an interesting subject. Otherwise, we can move on to something else. I went to use the last part.
There was a question on YouTube. Alexander actually looks like he might have answered it. I just wanted to see if Artem, if that was a good enough answer for him.
Do you know what the question was? Because I'm not seeing.
Yeah. So the question was, if you have more than one OpenSIPS in chain, how do you prevent doubles of messages when caching HEP messages?
Well, the real question is if you want to do that or not. the instrument here is made to tell the truth. So if a message actually was sent and landed in a different system, I mean, it depends how you're looking at it. It's not the same message, right? So one was sent, one was received. If you're looking at both, you shouldn't make an assumption that you might only want to see one, especially because, again, this tool is made for when things go bad. And when they go bad, when something is down, you want to see what's sent and what's received. You cannot make an assumption that just because something is shipping out of a server, it actually makes it to the other side. So that's something that we actually talk about a lot with our customers. It is a decision in terms of duplication. Sometimes you do want duplication. And of course, we can conceal it. So if you can afford, let's say, understanding your capacity. So if you say, okay, look, this is critical for me to know what leaves and arrives at the other side. I know it's the same message. I know it's my same system, but I want to allow this duplication for the purpose of being accurate. They can. We help them understand how it's going to be reflected in their capacity, and that's it. Other times, we have, low resources and we got to squeeze everything out. In those cases, it's sort of a, blacklist, whitelist type of thing where basically you would, every next element or every proxy basically would be assumed to be the best point to capture something, and the other endpoints might ignore it, or vice versa. You might decide to only sniff at the, at your back-to-back user agents, which is where the forking happens, and make the assumption that the proxy in front of you has seen exactly the same message and there's no need to duplicate it. So those decisions need to be made, with a full understanding of the architecture and the type of services that it's got to support, because once again, you're going to use it when it doesn't work. So that would be my 2 cents, but probably Alexander had a better point. Join in, Alexander, if you're here.
Alexander, are you here? The other Alexander.
Well, what's next? So a few things that, one might take as their next challenge now that you have a basic instance up is, as we were saying, implement HEP on all of your other systems. If they're already compatible, just do it. If they're not compatible, just pick an agent and install it. We have passive agents such as Amplify, Capped Agent, and a few more, depending on the source data. You can just throw on top of anything, your little AWS instances or whatever else. You can configure mapping and correlation to go deeper into how your network relates. So you can teach Homer how to correlate back-to-back sessions, or use specific headers to determine correlation, much like OpenSIPS does internally. You can start building dashboard and alerts with the time series that we generate, and there's a lot of them. Actually, for Prometheus, we already have some decent defaults that are from NAGB that already, paint a nice picture, but in there, it's a gold mine of metrics. They could be used for a number of purposes depending on, the type of application. It could be super technical, or they could be just, for, let's say, consolidation. Am I measuring as many calls as CDRs? So comparing what we see passively with the active view. You can implement external data lookups. This is, I think, the coolest feature, at least for me, with HEPSUB. If you don't know what HEPSUB is, it's on our repository, SIPCapture/HEPSUB. This is a new way to develop extensions for Homer without touching Homer at all. So it's kind of a PubSub API where you can publish some capabilities. So like you can write a little agent that says, I can look up CDRs. This is actually connected to CGRateS, which we happen to have a working example for. Ax, who's on the call here, actually made a lot of that happen. So you can have a middleware that sits outside of Homer. It advertises itself to Homer, and it can receive a query every time a user interacts with it or its API. So if a user goes into the UI, they click a session, by using mapping, we can decide that we're going to send the call ID, for instance, or the session ID to this HEPSUB agent, which is itself going to perform some lookup. They can be in any language, they can be done in any scripting, it doesn't matter, they just have an API in common, and they can return data. So this way, I can open a call in Homer, I can take the call ID ABC123, I can have one of these sub-agents perform a lookup into CGRateS, for instance, and return a CDR that I can display inside of my window right there without the user doing anything. So many of the things that one would do kind of in chain can potentially be automated. So you can write a little agent that's all yours. It only exists on your local network which does the job for you and just returns the data, be it looking up logs in Elasticsearch. We even have a plugin, actually, this is quite fun that some people should really try it, which is for Void Monitor. So we have a HepSub agent for Void Monitor. So you can use the sniffer of Void Monitor, which is, of course, also open source. And it's interesting for some aspects. You know, you can generate recording. If you want to break the law, you can do that. And there's a HepSub agent that can actually go and take CDRs and PCAPs and WAV files from its database. So it's a little adapter, basically, for another database structure that returns data that we might care about. If you go into the next one, I would highly suggest reading about the Janus and Homer integration as well. It's a long story of love and passion that we have been carrying on for a while. Not many people, I think, use it to its full extent, but it's there. Some things you have to put in place long before you actually need them for them to be useful. But inside of Janus, there is a powerful event emitter that tells you basically everything that's going on and a lot of granular information about streams and stuff that can be tracked with Homer. What Homer does is basically take all of those events, which are JSON objects, and some of them it will save them for search. So things that are related to, let's say, decisions or user-related, parameters and stuff. And everything that's related to media, we actually read it, throw it away, and turn it into time series. So we take all of those objects that are, just reporting about, the quality and the performance of the streams, and we turn them into time series in your time series backend of preference, same as above. You can choose any with the tags. So we have a tagged way of looking at media statistics, so full-on WebRTC stuff through Homer, and they can be connected to anything. So if you're using the SIP plugins there, they will automatically correlate. But if you're not, you can still come up with some method of your own to correlate them. Another super cool feature, and this is the one that I'm really in love with, is the fact that you can use OpenSIPS as a HEP switch. So basically, OpenSIPS can do with HEP what it does, let's say, in the baseline for SIP. So you can take HEP into OpenSIPS. You can modify HEP packets. You can decide where they go. So you can either fork them or route them. So you can decide that all of HEP packets with a certain feature will go to Homer number 1, and all of the others will go to Homer number 2. So you can use it to load balance, switch packets, and do probably a lot of things that nobody has thought of yet. And of course, you can generate HEP itself. So it's super, super powerful, and it can be put inside of any Homer deployment, really, to provide similar advantages as what you would for the SIP part. So another role for OpenSIPS that it's completely new and future-proof is that exactly can also load balance and help with HEP. Do I see Alexander join?
Yes, sorry, I'm here. I was on YouTube, but now I joined.
Now you're live.
Yeah.
And the last thing is, of course, that you can extend it. So come and design an extension. Let's add a new protocol. Let's make a new widget. We're looking for problems that we can solve. If you're a developer, of course, and you have even, from a PR all the way down to just an idea, join us, open an issue, come on our channels, talk to us because we're interested and, we're simple guys. If you're have a professional level problem as well to solve, contact us. We have done this thousands of times and all of them successfully. So we know how to go, from the simple things that we're looking today all the way into like gigantic clusters with, billions of calls. I have a few links here, just if anybody wants to take a screenshot, but, this is stuff straight off our, wiki and everything else. So nothing, nothing that you wouldn't find anyway, but I thought it was easy this way. And now that we have Alexander here, if you really, really want to win a Homer t-shirt, we have some really cool ones. And all it takes is to send us a cool tweet, a selfie with your Homer setup at SIPCapture. We're going to submit all of the entries into Live AI, and the machine learning algorithm is going to pick some winners. So, it's still warm. It's a cool t-shirt, and you can see an example of it worn by a great artist, Lorenzo Miniero, who's up next, by the way. So we're at the end of it. I don't know how many of you actually were trying to do it. If you did, of course, you can contact us, sideways on the channels and whatever else to help you perfect it. If you have any questions, this is the time, because we also have Alexander, and you don't get much of Alexander. These 10 minutes are super expensive.
Yeah, what to do? Implementing new protocols. Yeah, and so.
Or we can talk about, the history of HEP from the far west to the modern times, which is also something that we're fond of.
Yeah,
Can you tell us more about the REST commands and the URL in the OpenSIPS configuration? What does it do exactly? Maybe this is one for the OpenSIPS guys, if you guys want to come in.
Yeah, I can pop in for that. So can you switch to that slide, please?
Yes, I'm trying. We're talking about this one.
I don't think so.
REST
Is it
command.
this one?
So the REST command and the configuration. Okay, so we're talking about this one. Sorry.
Okay, so basically this this small snippet says that for this particular, let's say, message, or depends on how exactly you end up in this route, this indicates what kind of tracing you want to do. Do you want to do it at dialog level? Do you want to do it at transactional level or not? So this is the trace type. The trace ID indicates what kind of tracing you want to do, because besides HEP tracing, we can also do SIP tracing. For example, if you want to duplicate the entire traffic over SIP, so not necessarily HEP. Okay. The second parameter is whether you want to do dialog or transaction tracing, and the third one is the type of messages that you are interested for. So, for example, in OpenSIPS, besides SIP, you can also do logging, as Lorenzo already showed you, and you can also do REST queries. So basically, you can track down the REST queries that you perform during dialog. Does that answer your question, or?
But it's also interesting, probably in this case, because the guys from OpenSIPS, they can do also transactions, and they can send to HOMA from OpenSIPS directly CGR record, which you can display in HOMA.
Yes, correct.
TDR, because we track dialog transactions, and it's good feature and great feature exactly to see duration of call and et cetera, et cetera, et cetera.
Yep.
We're making a patch live. Great.
What kind of patch was something? Was there a typo or something?
Yeah, I had commented out by mistake the REST module when I committed, so I have it in the live system but not in the config. Now it's looking spotless. So here we go.
So
all right.
Mark was asking about the REST get command. Can you go there, please?
Liviu, you're muted. Do you want to tell something?
Where is the REST get?
I think Liviu is attending the other conference that is in Paris, so that's probably why we can't hear him, or he's not involved. That one. Okay. Okay, Lawrence, go ahead. Tell me what that line does, or I can do it. But
so if it's a method invite, it sends, it checks correlation HEP. Yeah. Okay, so it's normally you send to external API server with invite, and it makes analysis and try to guess if this call is correlated to another session and give you back.
Yeah, give us some type of a reply, and the reply should be mirrored back to HEP.
Yeah, and you can do remember, Lorenzo, this is exactly a special HEP protocol when you can put multiple correlations array.
Yeah.
It's exactly what this command does.
Yeah.
And in this case, you can correlate your call to and external sessions. For example, let's say you have SS7, yeah, or you have Migakumi and GCP, whatever, or special Janus protocol, yeah. And in this case, you can have OpenSIPs, and an external API server can do correlation across multiple protocols and give you back correlation array, which you can use in Home to display all data at once.
Well, I think Mark is just asking what's the what the
Okay, sorry.
CID lookup does. It's basically a LRN lookup through REST.
Yeah.
It's not particularly related to Homer itself, but yeah, you can fetch more information about
More data, yeah, and put it.
Exactly.
Yeah.
Ideally, I guess this wouldn't be on purpose for tracing. It might be something else that you're doing as part of your validation, you know, getting a token if a user can proceed or not. It could be like, you know, whatever you're actually using. So the idea is not really to make something on purpose for it, although it can be used that way, but rather to give you ways to trace the decision-making process within the platform. So if a lookup is part of it, then, you know, it should be mirrored to understand the decision that the switch made.
Yeah.
That is correct. And note that you can also do this asynchronously. So you can use the REST-GET in an async way, therefore enhancing increasing the performance of the script.
And by the way, this is the case also for other, you know, HAP scenarios. So let's say that you want to backfill some logs, or you have a batch process that reinserts some data in non-real time. It's all fine as long as you have accurate timestamping. So all app agents do require to have microsecond timestamping or have fields for it. So if you do that part right, you can also backfill logs from you know, days ago, hours ago, weeks ago, whatever, and you can have batch operations send, you know, data in the right time, even if they're not generated at the same time. In most cases, this type of investigations in Homer will not be done in real time. There will be, you know, complaints or something, or an escalation or a case that you go into the system and look up data for. So, you know, as long as it comes just before, in real time, or later at any point, HAP keeps it flexible by giving you the ability exactly to generate data in the past as well, or to write it in past tables. All right, so I just want to do another share here for anybody that's going into the next adventure. If you want to link Janus and Homer, since I assume you're going to be in love with both by the time we're finished, this is how. So HAPOP is the capture server for JSON types. So it's going to support, or it does support, Janus, MediaSoup, Jitsi events even. It's a Node.js application. It's super easy, and it just fields in. So you can run this at the same time as the regular capture server with Amplify server and the rest, if you want to add JSON events into the platform. And we'd love to have more users here. So if you come, just you have issues, just you know, post them on GitHub. We'll be happy to help out. I think we made it in time. Thank you so much for listening again and for staying with us all the way through.
Lorenzo, we have another question.
That was awesome.
Oh,
Yeah,
sure.
we have actually some more questions in several places. Alexander, if you see him, go ahead.
No, okay. Can you please share the link slides, the one before the last slides once more?
I'll share everything right after. If you're on the Slack channel of OpenSIPS, you get it first.
And then did we get Mark Farmer's question?
I think we did.
I don't see any.
Rest
Okay,
command.
I have,
Yeah.
and I have another one. Okay, it's only about complaints about font size, very small. Nothing more on YouTube. No, I think that's it. Or
All right, guys. On behalf of the QXIP team, thank you so much for sticking with us. And we gladly hand it off to the other Lorenzo.
That was awesome. Thank you very much, Lorenzo.
thanks.
So that's right, ladies and gentlemen. Our next presenter's name is Lorenzo as well. There'll be a little change of atmosphere as far as the video goes. Another amazing project out there. He's going to give us a practical journey in the Janus and OpenSIPS world. Lorenzo, are you here?
I am. I was just in the process of sharing my screen. Can you all see it?
We can see it. We can see it.
Yep,
Okay, perfect.
fine.
Thanks for the introduction, and thanks also to Lorenzo for the kind words and for the link to the presentation. I'm really excited to be here. I mean, I think it's my fifth time in a row at OpenSIPS, so I'm really enjoying the really good atmosphere that this event gives, even if we are all remote right now. It's not the same thing as being in Amsterdam, but it's really close, at least for me. And in this presentation, actually workshop, I'll try to give you a bit of a glimpse inside of what you can do using Janus as a WebRTC enabler of sorts. So basically as a way, a component that you can put in front of OpenSIPS to take advantage of WebRTC features and still take advantage of all the cool things that you can do with OpenSIPS at the same time. And basically, I'll show, I have both Janus and OpenSIPS installed in my machine, and so I'll try to replicate a bit of different use cases and show you how you can do a few different things. So I'll show a few slides just as an introduction, but then I'll try to give you some practical examples using a practical demo, basically using a few different endpoints on my local instance here. So without further ado, just a couple of words about me. So I got my PhD at the University of Naples a few years ago, and I co-founded a small company based in Italy that is called Miteco. And I'm the main author of Janus, which is the component that I'll be talking about today. And here you can find a few links to get in touch with me or to see some of the presentations that I did in the past. And as I mentioned, I made many presentations at OpenSIPS as well. So you may be interested in having a look at those as well if you are interested in what I'll present here today, plus a few links to my hobbies too. And just very few words on my company as well. So we co-founded it about 10 years ago as an academic spin-off. And our focus has always been on real-time multimedia applications. So with a strong focus on the standardization aspects as well, which is why we were very interested from the very beginning in SIP, RTP, and all of these protocols. And so as soon as WebRTC came out, we of course had to jump on that. And we provide different services around that. And we are based in this beautiful city that you see over here. So our office is around here probably. I don't think it can be seen from the picture, but that's about where we are. And so let's move on. So first of all, I wanted to clarify that while this will be a workshop and I'll try to give you some details, I will not go very much in detail about what the SIP plugin does per se, mostly because that would take basically a whole presentation to explain. And in fact, that's exactly what I did, for instance, last year at the last year's OpenSIPS Summit. So if what you see today interests you and you wanted to learn a bit more about how the SIP plugin works specifically, or how you can actually use Janus with SIP with different things from a more, let's say, architectural perspective, you can watch this presentation on YouTube because I go very much in detail about all of these different aspects that you can see over here. I hear some background noise. Could you, Peter? Could you mute, please? Thank you. And but anyway, just to give you a quick reminder about what Janus is, it's basically a WebRTC server that can also act as a gateway. So I'll share a few details about specifically how that can happen. But here you can find some links. More specifically, you can find the link to the GitHub repository where you can download Janus. We also have several demos available online for you to play with, so without you having to actually install everything in your setup first. And the same website also contains some documentation too, if you want to have a look at the different things that Janus can provide you with and how the different feature works. And we also have a quite active community on Google Groups where you can also engage other Janus users to see to basically ask them questions and possibly find out how to solve any issue that you may be experiencing. And I was mentioning that Janus has some kind of a modular architecture, and this picture tries to explain it a bit more from a visual perspective. So imagine you typically have a browser with a WebRTC stack that wants to join some sort of multimedia communication. What you typically end up doing is you have some signaling with via HTTP or WebSockets or something else, and you may end up creating one or more peer connections, so one or more media channels. When you talk to Janus, this means that each of these peer connections that you see over here may actually end up talking to the same or to different plugins at the same time, depending on what you actually need to do. And for the sake of this presentation, what is actually interesting here is this red arrow over here, because it explains how you can actually have, for instance, a browser using a WebRTC channel to talk to Janus, and then in the backend exchange some communications with any legacy, and I say this in quotes, of course, because SIP is not really a legacy protocol, it's very much active, but in theory, that's what you can do. So you can basically take advantage of having a WebRTC peer connection over here, and then have Janus, or better, one of the Janus plugins, take care of the communication with another protocol that may not be 100% compliant with WebRTC, which is exactly what would happen with the SIP plugin, for instance. In this case, any peer connection that you have over here may be tied to a SIP dialog and SIP call on this other end as well. And this is all made possible, first of all, by the fact that these different plugins, where one plugin may be a SIP plugin, another plugin may be a conferencing plugin, and so on, they all have their own sub-protocol by which you can communicate with. So this means that, for instance, as we'll see, the SIP plugin has its own methods by which you can create resources, register accounts, make calls, and so on and so forth. And this sub-protocol is, of course, very different than the sub-protocol that, for instance, the conference plugin may want to use. At the end of the day, all of these messages are exchanged on top of the Janus API. And in fact, as we'll see later when I'll show some of the demos in a more practical way, this means that you'll always talk to Janus using the Janus API on one of the transports, and so using some custom JSON protocol that we devised. And more specifically, in the case of the SIP plugin, it means that you always talk and you always exchange very basic JSON messages with the Janus server, and you never actually see any SIP message from the browser instead. Any kind of SIP-related detail actually lives and takes place within the SIP plugin. And again, I'll show this graphically in a second. But before going there, I wanted to share just a couple of slides to give you a few details on how you could, for instance, install and configure Janus. Again, I will not go very much in detail in this because that can actually take a bit more time if we wanted to go in detail in that. And there are actually some workshops that are recorded at other events that are more generic and that you can refer to if you're interested in more information. But I just wanted to share some very brief instructions just to show that it's actually very easy to install Janus. And actually not that very different from how you can install, for instance, OpenSIPS or other open source projects that you may be familiar with. Of course, we provide a lot of information in the README with the different steps that you need to follow, but really in a nutshell, it's quite simple. So first of all, you typically install the dependencies that are needed, both from the Janus core and the plugins that you are interested in. Some dependencies you may have to install manually, either because it's packages that are not available in your repositories, or because there are some updates in the most recent versions that are not available in the repo versions. And for instance, we definitely recommend installing libnice and limbsrtp2 manually. And sometimes it makes sense to also install Sophia SIP manually as well. And Sophia SIP is the SIP stack that we use in the SIP plugin to provide all the SIP functionality. Once you have installed all the dependencies, it's just really a matter of the usual installation process. So you call autogen and then you configure what you want to install, and then it's just a matter of doing make and make install to build and install everything. And to install the sample configuration files, which you typically just need to do once, you just call make configs, which will basically install the sample configuration files that are available in the repo so that you can tweak them to do what you need to do. And talking about configuration files, our configuration files are typically quite straightforward to follow. They are in the so-called libconfig format, because we initially used ini as a format for configuration files. Now we use this other format that is a bit more flexible and allows us to do some more complex things. And it's actually quite straightforward to understand, because it's always attribute equals value kind of thing, where the value can also be an object, in this case a category, or it can be an array, or it can be a number, a string, or a Boolean, or these kind of things. In most of the times, we just use either global properties or category level properties, which can be these different types over here, but we have started already adding some more complex categories at the same time. And an example of a configuration file is this one that you can see over here, which is a configuration file for the Janus core in this case. So we have a few different properties, for instance, the RTP port range for the WebRTC media, in case your Janus sits behind the firewall and you want to limit the number of ports that can be used for WebRTC purposes, possibly the interfaces that you may want to bind or not bind to, this kind of things. But of course, you may be interested in having more a look at how the SIP configuration file looks like instead. And this is because each plugin in Janus, whether it's a media plugin or a transport plugin or so, whatever, typically has a configuration file of its own that can tweak a bit of some of its settings. And again, I will not go too much in detail in this, also because if you have a look at the documentation or the configuration files in the repo, they are all documented. But just to give you an idea, for instance, we have an RTP port range for the SIP plugin as well. And this will be clear why in a minute, mostly because, as I said, the SIP plugin acts as a media gateway between the WebRTC side that is taken care of by Janus and the SIP side, so the SIP leg that is taken care of by the SIP plugin instead, which means that whenever you create a peer connection to originate, for instance, a call towards a SIP device, you actually need to create a SIP dialog, you need to create a SIP stack, and you need to create a media stack as well, which means that you need to allocate some ports for the SIP side of things as well for media. And so if you don't want the WebRTC ports and the SIP plugin ports to clash, you can basically configure different ranges in there, for instance. And there are other properties that you can configure that are related, for instance, to the registration properties, or even the IPs to use and to bind to for the SIP and media part. And I wanted to highlight this property over here because this property was actually provided by Razvan last year, so we are very grateful for that. So he was actually playing a bit with Janus for his Janus core presentation, and he found out that he needed this kind of functionality, and so he installed that. So just to move on, sorry, did somebody mention me?
I was just thanking you for reminding me.
Oh, okay, sorry, I heard somebody. Thank you. It was really welcome. It was a really welcome contribution. And so from a graphical perspective, this is how the Janus plugin works. And I want to focus to spend a couple of minutes on this slide also because it's usually a bit of a source of confusion to people who approach the SIP plugin for the first time. So as I was mentioning, typically you have WebRTC users using either, for instance, HTTP or WebSockets to talk to Janus using the Janus API, eventually creating some WebRTC peer connections over here. What this means when you use the SIP plugin is that typically a peer connection is associated to a SIP call on the other end, which means that, for instance, this user wanted to call a SIP device, use the SIP plugin to actually originate a SIP invite, which is what the SIP plugin does. So the SIP plugin creates a SIP stack on behalf of this user internally, in this case using the Sophia SIP plugin. And so if this user wants to call somebody, it means that it creates a SIP invite that it will then send to the SIP infrastructure on the other end, which will eventually result in the creation of a RTP session over here as well. And at the end of the day, this means that any RTP packet coming from this direction will be sent on the WebRTC leg as well, and vice versa. So any RTP packet that this user is sending via WebRTC to the SIP device is relayed over RTP as well. And you can see that there is an S in parentheses over here because we do support SDS SRTP as well in an optional way, even though most of the times just plain RTP is used. But I wanted to stress out the fact that in this case, Janus and the SIP plugin in particular is creating SIP endpoints on behalf of users that want to take advantage of the SIP functionality, which means that you should see the SIP plugin as a SIP client, as a SIP endpoint. So you should never see the SIP plugin as, for instance, a SIP proxy of its own, or a SIP back-to-back user agent, or any kind of SIP server functionality. It doesn't work like that. So you just have to assume that the SIP plugin here creates an internal SIP endpoint that you should treat exactly as you treat other SIP endpoints like a soft phone or a hard phone or something like this. So an endpoint that you will send invites to or you receive invites to, an endpoint that can register on behalf of this user and these kind of things. So this is very important so that you are not confused, for instance, in what actually the SIP plugin can do for you. So sometimes people think that using the SIP plugin, you can actually replace this SIP infrastructure over here, which is most definitely not the case. Well, what we wanted to do was actually provide a very easy way to provide WebRTC functionality and interact with the SIP infrastructure that may not even know that there is a WebRTC word behind this component. So you can see, again, here, Janus mostly as a WebRTC enabler for a SIP infrastructure that may be completely unaware of WebRTC things. And in fact, the SIP messages that you'll see over here will most of the times just go over plain UDP, for instance. So it's not really that different from any kind of interaction that you already have with endpoints. And of course, the main target of this demo here is showing how you can interact with OpenSIPS in particular. So as I mentioned, I installed OpenSIPS a few months ago. It was actually a nice experience, so I expected it to be harder than it was. So I encountered a couple of issues, and the OpenSIPS guys were really nice and helpful and helped me fix those right away. And eventually I ended up with a test bed to play with very quickly. And more specifically, I configured my OpenSIPS instance to act also as a local registrar, which means that this OpenSIPS instance that I have locally is the only one that I will interact with. So it will not involve multiple instances or things like this, mostly because I wanted to focus more on this communication here. So the communication between Janus and an OpenSIPS instance. But of course, if you start testing it with multiple SIP servers in the middle and with more complex deployments, the same things that I mentioned today should pretty much apply here as well. So nothing much changes. But I was just mentioning that I'll basically show how you can register to an OpenSIPS instance to be able to start and receive calls, for instance. I'll show you some examples of how you can send some typical SIP messages without knowing anything about SIP. So, because again, this user just sends some JSON messages, it doesn't know anything about SIP at all. Some more advanced stuff like putting calls on hold or doing call transfers, these kind of things. So I'll try to show all these from a slightly more practical perspective using all web browser-based endpoints. So there will not be any actual SIP endpoint. All the endpoints that will be involved will all be WebRTC users using the Janus SIP plugin to communicate using this OpenSIPS infrastructure. And more specifically, I will have 3 different accounts over here. We'll have Alice, Bob, and Carol. And even though they all share exactly the same code, so the web pages are exactly the same and the JavaScript code is exactly the same as well, I used different colors for their web pages just to make it immediately apparent when I switch, for instance, tab to show you how the different things work, who is actually doing what. So just to make it a bit more clear. So for instance, for Alice, I will have a purplish kind of navigation bar. For Bob, it will be some sort of a green navigation bar, while for Carol, it will be orange instead. So which means that we'll have something like this. So in this case, you can see I have 3 different tabs. And I'll basically show you how these different tabs can all interact with OpenSIPS in their own way, so that I can have, for instance, Alice call Bob, or Bob ask Alice to transfer a call to Carol, and these kind of things. And I'll also show, I'll also have the JavaScript console open here, mostly because I want to show you some of the messages that are being exchanged, mostly because, as I mentioned, the communication between users and Janus will always use the Janus API and the custom sub-protocol that we use to communicate with the SIP plugin. So I'll basically show you, for instance, when I do a register, I'll show what this means in terms of Janus API over here. And I'll show you, using this Wireshark that I have open over here, how this actually translates to SIP dialogues that the Janus and OpenSIPS are using to interact with each other. So I'll basically try to show you a bit what's happening behind the curtains. So let's start exactly with that. So let's start with how you can actually register with the Janus instance. And so let's start with Alice connecting. In this case, as I mentioned, I have Janus and OpenSIPS both running on my same machine. So it will be not a very realistic use case, but again, it's very simple, but it's very effective. And so I have an endpoint registered for Alice. And so in this case, I'm just providing the SIP address for Alice over here. So I will not specify a username or a different SIP registrar. If I just specify the SIP address as it is, Janus already knows that this is the address that it should send the register to, basically. So it's a simple and convenient way to do things. And the password is, of course, the unbreakable Alice. I can choose a couple of different ways to register. I'll just use the plain secret just for the sake of simplicity. And I'll send my register now. And now magically I have registered. But what has happened behind the curtains? And of course, I forgot to start Wireshark, so please bear with me. I'll do this again very quickly. So what has happened is that if I have a look at the DevOps over here and specifically at the communication that I had with Janus, several different messages have been exchanged. I will not look in detail about the Janus API details themselves, but I will focus on the messages that I exchanged with the plugin instead as soon as I connected to it. So what I sent here was a request register, which means that the plugin knows that I'm trying to register a new SIP account. This is the secret that I provided, and this is the username that I wanted to provide the register as instead. As you see, I didn't provide any server here, even if I could, and I'll show you how you can do that later. In this case, since I didn't provide any specific server to connect to, the Janus plugin knows that I'm interested to use this part of the domain of the URI to actually connect to. And this is exactly what happened eventually. So when I sent this message, the plugin started acting on it. It for instance, sends me an event to say that it's attempting a register because it's an asynchronous operation. And eventually, I ended up connecting successfully to the server. So eventually, the SIP plugin will tell me that I have registered, that I have this master ID, and this will be important later. I will not spend much of it right now, so I will just mention that this is important for a few reasons later. That I actually did send a register, and I'll show why this is important later, and this is the username that I chose. And what happened on the server side was, of course, this. So what happened is that between user and Janus, I was just exchanging some very basic and simple JSON messages, but on the server side, Janus originated a SIP endpoint on my behalf and actually sent the actual register messages on my behalf. So here you can see this is the message that it sent. You can see that this is the user agent here, the Janus WebRTC server, that this is the address that I wanted to register. And this is OpenSIPS actually answering me. So first of all, with the 401, because I need to authenticate, I provide the correct credentials, and eventually I registered. And if I can do, of course, the same for some other endpoints as well. And if for any endpoint that I do this for, basically Janus is creating a different SIP stack, which means that Janus is basically a collection of different SIP endpoints that live their separate lives. So I can do this same thing for Bob as well. And the result will be exactly the same, but with the difference that I now registered an account for Bob as well. So I will see some more exchanges over here for Bob instead. And a few different interesting things here are that I can actually do a few more complex things when I register. And more specifically, if we look at the code, one of the things that I could do, for instance, is that I could provide a specific server to connect to if it's not the same as the SIP URI that I'm trying to register. Or I can specify an outbound proxy. I can even add some custom headers if I wanted, and I can show this very quickly with one of the accounts, for instance. So if I uncomment these lines over here. I can also uncomment basically I can also configure some contact parameters if I wanted. So that's something that may be interested as well. Let's do that as well, just for the sake of demo purposes. I can update this page over here. If I restart the web page for Alice and connect again, and have a look at the traffic, what happens is that, as you can see, we have in the SIP transaction that Janus actually originated on my behalf with the SIP infrastructure, there are a couple of headers that were added manually by the SIP stack itself. So all I had to do was basically add a couple of properties in the JSON object and they were done. And same things for the contact parameters. So in this case, for instance, you can see that I added some contact URI parameters over here, and they were added to the request as well at the same time. So as you can see, even though we are not providing any SIP functionality directly from the web browser itself, it doesn't mean that we don't have some level of customizations on what the actual SIP communication should look like. So we tried to make it as simple as possible to use from a web developer, but at the same time still providing some of the functionality that some more advanced users may be interested in, especially because the SIP infrastructure may require them, or for instance, because we are interacting with IMS and you need some specific custom headers to use in this case. So now that we've seen this, let's comment all this stuff again. And let's have a look instead at what we can do with codes instead, which is of course the most important part in a communication. And in this case, even calling is actually very simple when you use Janus with the SIP infrastructure, because as we see, it can also be as much as 2 different properties that you send to Janus. And more specifically, let's have Alice call Bob here. All you have to do in this user interface, this demo user interface that I provided here, is provide the SIP URI that you want to contact, and this is all the SIP information that you really need to know from the application level. When we try to start a call via Janus, basically Janus will originate, as you see over here, an invite, which reaches the endpoint over here, and we can either answer or decline. Let's decline here for the sake of demo purposes. In this case, we had Alice sending a message to Janus, Janus sending a SIP message to OpenSIPS, OpenSIPS sending a message to Janus again, because that's where Bob is as well, and the Janus SIP plugin forwarding the incoming SIP information, so the incoming SIP call to Bob, so that the application could decide whether to accept or deny it. And if we have a look at the traffic that is implied on the web page specifically, it means that we first of all send a message to start a call, which very simply means I'm sending a request to call somebody, and the somebody that I want to call is this URI, so the one that I provided in this field over here. I'm also asking not to automatically accept re-invites, which is a feature that Janus provides by default. This is because, for instance, I may want to start audio only and then load video and so on and so forth, while Janus by default tries to automatically accept all renegotiations for the sake of simplicity without involving the other party. This way we make it explicit. In this case, what happened is that, first of all, I received an event, so some indication that the plugin was really starting to do a new call. Here we received some notification about the fact that the other side is ringing. So we actually received a ringing event from the SIP dialog, and we notified it on the Janus side of things as well. We actually can notify some more specific information related to SIP as well, if you're interested in about it. So for instance, we can relay the information that we received the 180 code from the other end, which may be interesting and important for the application side of things, because for instance, you may want to play a ringing sound or something like that. And apart from a few messages that are related to the WebRTC side of things, eventually I received this event over here that told me that the call had actually been rejected. And more specifically, I received a hang-up event, and the hang-up was basically specialized by the fact that I received a 486. So Bob basically sent me a busy back, and the reason was busy here. So I received all the events I needed to basically handle the state of the call without having to worry about handling too many SIP-related information. So let's have a look at what happens when you accept the call instead. Since we are persistent, we try to call Bob again. In this case, Bob accepts. And here I am. So now I am in a call with Bob. So let's have a look at the stuff again. In this case, you can see basically that, let me see if I can find it. Okay, I sent a new message over here. And in this case, the message was pretty much the same as before. So I'm again sending a call request, and now I'm inviting Bob to the conversation. What happens is that eventually, after the 180 preceding events that I already received, I actually receive an event that tells me that the call has been accepted. So, and the event in that case looks like this. So I receive an event accepted instead, and it tells me the username that accepted the call is this one, even though this is implicit because this is the URI that I actually called. And from the WebRTC side of things, it means that the Janus API also contains an SDP answer that I can use to actually finalize the setup of the WebRTC peer connection, which is why I basically end up with this WebRTC app event that you see over here. So this basically is just an event that Janus sends to confirm that the WebRTC connection has been established. And at the same time, a SIP dialog has been successfully established on the SIP side. So between Janus and OpenSIPS and the other device that was involved in the communication. So first of all, before I proceed, is this clear enough so far, or do you have any doubt? So any question that you have on the first parts of this introduction, this presentation?
Looks good to me.
Okay. One more thing to say is that let me hang up here because otherwise I'll hear myself. One more. Because I was basically hearing myself because I was in a call with myself also as Bob and Alice. So let's fix that by just adding some properties here. So this is the code where we basically add all the information to create a remote audio and video stream. So in this case, normally you want to hear the other peer. Since the other peer is me and I don't want to hear myself once more, I can add another muted equals true property here. So that should be better. And let's make it explicit like this too. Just a second, sorry, demo time. Okay, we should be all set now. So one more thing that I wanted to mention is that exactly as we did with the register, we can actually also provide some additional information when originating SIP calls as well. So in this case, for instance, whenever I actually send my call request, there are a few things that I can configure. So for instance, I could specify, let me find the right place. Okay, this is the code that we have where we actually originate a SIP call. So as you can see, very simply, we send a request call and the URI that we want to call. We can add some more information like the fact that we want to auto accept reinvise, but some more things that we can do is, for instance, configure the SRTP properties, because for instance, we may want to use SDS SRTP within the communication. And at the same time, we can also provide some custom headers as well if we want it. So exactly as we did with the SIP register, we can add some custom headers to the SIP invite if it is actually relevant. So I will not show this again for the sake of brevity and simplicity, but you can assume that it works exactly the same way. So let's just show some additional things that you can do while you are in a call, some more simple interactions. And more specifically, let's start a call between Alice and Bob again, hoping that it's muted as expected now. Let's call Bob. Bob accepts the call, and I hope I didn't add any exception over here. Okay, so never mind these small UI glitches. They're probably related to the small change that I just made. But eventually, we have Alice and Bob in the same call with each other. And what we can do now are a few different things. So, for instance, I may want to send Bob a message. So in this case, I can say, "Hi, Bob. Pizza is good," which Bob will receive on the other end. And what I would just send was basically a SIP message. Again, I just sent it as a very simple JSON object instead. So if we have a look at the traffic, you'll see that I have a request message and content, which then Janus translated for me to an actual SIP dialogue with the message body that I wanted to send. So it's a very simple and effective way to actually send a SIP message on the other end and at the same time receive an event at the same time. So if we want to see how it looks like for incoming messages instead, we can have Bob reply, "Yes, but only without pineapples." And so if we have a look at the traffic again, we'll see that there is an event over here. And this event includes the actual message that I received. So this is how the Janus SIP plugin tells the application that they received the SIP message. In this case, they said, this was the sender of the SIP message. It is a SIP message, and this is the content of the message. So again, a very simple and compact way of conveying the same information without having to actually bother crafting and parsing SIP messages yourself on the web page. You may want to do some more complex things. So you may want to send, for instance, a SIP info message instead, like an application XML object with pizza type pineapples. Good. And the SIP endpoint will receive it pretty much the same way as we received and sent the SIP message, with some additional information like the content type, for instance, so that you can parse it accordingly and so on and so forth. And the same can be done by Bob on this side as well. And one interesting thing is that while we can send DTMF tones within the SIP, within a SIP dialog, these are typically sent in band with the media itself. It depends on the browser on whether they are actually sent as basically payload type events related to the DTMF payload format, or if they are actually encoded in the audio stream, but they are typically part of the audio stream itself. We do support DTMF via info as well if you need it though. So if this is not integrated into this web page over here, so I'll do this manually, but basically how it looks like is you can send a message like this. So you basically tell Janus to send a message that looks like this. So this is the message that we will send to the SIP plugin. We'll ask for a DTMF info where the digit that we send is 3. So what happens when I send this is that the other end will receive a SIP, a notification about this into a format that it is able to understand as well. And more specifically, in this case, this is the format of the SIP DTMF, the DTMF info via SIP. So again, it's a convenience way of doing pretty much the same thing without you having to worry too much about the specific format of the info message. So for DTMF, we have this convenience method, but of course you could have sent this kind of info yourself and crafted the DTMF info yourself if you wanted. This is just a convenience way to do pretty much the same thing. And let's move to another thing that you can actually do, which is holding calls. And holding calls is actually quite simple with Janus because it's just a matter of sending, again, just a very simple request on the other end. So, and more specifically, and this is not integrated in the UI, so I'll show you from the console instead. This is the message that you need to send and nothing else. So if you send a request hold to Janus, basically the Janus plugin will automatically be able to figure out that you actually want to put the call on hold, which means that it will send on your behalf a new invite. The new invite will have the SDP updated so that in this case you are just doing send only for the audio stream that you are receiving, and you're not interested in receiving the audio from Bob for the time being. At the same time, this is the reply that Bob sends on your behalf. And once you are done with putting the call on hold and you want to restore it, nothing else that you need to do is just say unhold. And this again originates a new SIP invite where instead it restores the media direction as it was before. So as you can see, a very simple and convenient method to avoid you messing with media directions yourself and updating media directions or WebRTC stuff and so on. You just send a message to the other end, to the SIP plugin, and the SIP plugin takes care of updating the media direction details for this specific session. So as you can see, very simple and very effective. Of course, you may want to do some more complex management of media. So for instance, you may want to, I don't know, for instance, add the video stream to the call that we're having right now. So let's show how you can actually do this, hoping this will work because this is a small snippet that I added just today for demo purposes. In this case, we're doing an audio-only conversation that is now send-receive. If I want to also negotiate video in this session, what I can do is, again, it's not integrated in the user interface, but I'll show you how it looks like from the Janus API side of things. I can basically create a new offer. I say that I now want both audio and video, and then I send a request update to the other end. So basically, I'm just updating the session. This basically gives the Janus SIP plugin all the information that it needs. It knows that it needs to update the session on which this request is coming from. And it's actually the SDP that we attach on the WebRTC side of things that is actually used as the new foundation for the SIP invite. So let's try doing exactly that. In this case, we are being asked to share our video as well. Let's do that. And Bob on the other side should receive it. And of course, it's not working because of that change that I made before. But basically, you can, under normal circumstances with the demo that has not been mangled by the small change that I made before, you would now see video on both sides, on both Bob and Alice's side. So we basically have upgraded an audio-only call to video instead. So let's hang up this now to move to the next step of the presentation, which is basically multiple lines. So in this case, I've so far showed how you can create a single call between, for instance, Alice and Bob, but I may actually want to have multiple calls at the same time. So to basically simulate a SIP desk phone where you have multiple lines, for instance, where you can handle multiple calls at the same time. And I'll show you how you can do that. Let's add a new, let's register Alice and Bob and Carol again this time. Now, as before, let's call Bob on this line over here. And Bob accepts the call. Now, what happens if I have Carol that also wants to call me for some reason, or if I want to call Carol for some reason? If I try to call, if I have Alice Carol try to call Alice right away, what I will end up is clearly a busy here. And this is actually, this message never reaches this web page at all. It's actually the SIP plugin that automatically rejects this call. And this is because the only Janus handle that I have with the SIP plugin for Alice is already busy with this conversation that you see over here. And this is because in Janus, each handle can actually only have one single peer connection. And as we've seen, a peer connection is automatically associated with a specific SIP call in this case. So if I want to have additional SIP calls, I will have to connect to the SIP plugin more than once to actually be able to do that. But how do I do that if I have already registered? Because in this case, I have already registered Alice's information. If I try to register again, what I will end up with is a new SIP stack that basically replaces the previous one, and I will not be able to handle multiple SIP calls at the same time. And this is actually where that master ID that I was referencing before actually takes place. So that master ID is basically a unique identifier within the SIP plugin that tells, okay, now I know that Alice is associated to this unique number that I gave you. And now if from the Alice's webpage, I use that number and ask the SIP plugin to create a new handle for me, and I pass this master ID, basically the Janus SIP plugin knows that these additional channels that it is creating are all associated to the same SIP account. And this is because I already registered with OpenSIPS using Janus. I don't need to register again. All I want to do is being able to originate multiple calls or be able to handle multiple calls at the same time using exactly the same SIP stack, which is exactly what this button does over here. So it will basically add a new line that I can use for my own purposes. So if I have a look at this traffic over, at these things over here, let me see. I basically sent a new register message, but in this case, I didn't provide any credentials or anything like that. I just said I need a helper and this is the master ID that it needs to refer to. And I can provide this master ID because as Alice, I'm the only one who is aware of this. So you can see this as a secret identifier, a secret token that I can provide to tell Janus, I'm actually the same person as this other dialogue that you are handling, which means that if Carol tries to call me again, this time the call will succeed on this additional line that I created. And so as you can see, now I have another call on this side of things instead. So now let's try making things a bit more complicated. So, and we'll basically show how you can use all these multiple lines for a use case in particular that are actually call transfers. And this is, of course, multiple lines were very much a prerequisite for that, because if we wanted to support call transfers, we needed to have support for multiple call lines at the same time, because this typically means that, for instance, I have Bob and Alice in a conversation. Bob tells Alice to refer to Carol for something else. It means that Alice needs to be able to call Carol at the same time while still being in a call with Bob, and then possibly hang up a call with Bob after that. And this is exactly how we use helpers behind the curtains in this demo page over here. So let's just show these again very simply. We'll just show blind transfers for the sake of brevity. And as we'll see, actually the multiple lines will actually be created automatically for us from this specific web page. If you're creating a user interface yourself, it's something that you need to do on your own. But again, it's not very complex to understand. I'll show you the different steps that take place. So let's start again with Alice calling Bob. They really like each other, apparently. Alice calls Bob. Bob accepts. In this case, Alice and Bob are having a conversation, and then Bob decides to transfer the call instead. So what it says is, I'll transfer you to Carol instead. In this case, to keep things simple, we'll use the blind transfer here. So what this means is that Bob will send a request to Janus, more specifically a method that in the SIP plugin is called transfer rather than refer. So we'll do this. Alice receives this transfer. So she sees that Bob is referring her to Carol. So she can decide to accept the call. What happens is that automatically the user interface has created this additional line for us, because the user interface knows that it needs an additional line to call Carol. Carol receives the call and knows that she's receiving a call from Alice and she was referred by Bob. And this is all made aware to them because of the SIP messaging that was exchanged. And eventually we ended up with this call. And as you can see, Bob is also being notified via SIP notify about the different things taking place. So let's have a look at the traffic. Let's close this just to avoid the double audio too. If we have a look at the traffic, I can see that I invited Bob over here as Alice. Alice invited Bob, and this we all know. Eventually, when Bob asked to transfer the call, a refer was sent to Alice instead, with Carol's address in the refer to part, with the referred by having Bob's address instead. The SIP plugin sends the 202 accepted to Bob automatically, so nothing the user needs to do. And eventually, this refer was notified to Alice as well, which could then invite Carol at the same time, add the referred by information so that Carol is aware that Bob referred her to Carol, and so on and so forth. So basically, these you are probably much more familiar with than I am, because it's basically just the standard code transfer mechanism. What I wanted to stress out is that from the user interface side of things, so in the web interface, you didn't see any of that. You didn't see any of the complexity of the SIP messages. You just saw some JSON messages telling you that somebody invited you to a conversation. You received some additional JSON properties telling you who referred to whom, and this kind of things. So again, very simply, just JSON communication masking all the complex SIP details, let's say. Which brings us closer to the end. So, and I wanted to do a shout out to Homer as well, because as Lorenzo mentioned in his presentation before, we actually do support generating live events continuously about everything that is actually happening within Janus, and this includes the SIP plugin too. So it's more specifically, the SIP plugin will notify about all the SIP messages that it is aware of. So any SIP message that it is sending, and also any SIP message that it is receiving. And these will be sent as live events via our own event handlers asynchronously. And at the same time, we will also send live statistics about the WebRTC side of things. So you basically have all the information that you need to basically correlate a specific SIP dialog that you're handling to a WebRTC peer connection that is actually serving these on the WebRTC side of things. And all of these events that we shoot in real time can actually be handled automagically by Homer instead. And if you want to learn a bit more about this, and I'm running a bit short of time, so I won't go in much more detail about this, there are actually two different presentations that took place at the last edition of Janus, one where Alessandro from the Miteco team introduced event handlers in general, and then Lorenzo explained how they could consume these event handlers to show them in a much more organic and organized way in Homer instead, so that you could have a look at the traffic and do any kind of magic evaluation on that. And this basically covers all of what I wanted to show you in this workshop. I hope I didn't go too fast, or I wasn't too confusing on some of the aspects. So please, if you have any question for me, please just ask. I see no questions, so I can either assume that I was very clear or that I was very, very confusing. I don't know. Thanks, Coyote.
Come on, people. Questions? Let's see. We do have a couple of questions that are on the YouTube. I'll start at the beginning. Does Janus do the codec conversion as well?
No, so by design, we don't do any transcoding, or we don't touch the media at all in the SIP plugin. And this is actually done on purpose, mostly because we see the Janus SIP plugin, when they create the SIP endpoint on behalf of the WebRTC user, just as you could see as an avatar for a SIP avatar for the WebRTC participant. So it's actually just taking care of the SIP details on behalf of the WebRTC user, but media-wise, it just relies on whatever the WebRTC endpoint is doing. So anything that the WebRTC endpoint is offering, for instance, when they want to start a new session, that SDP offer media-wise, so in terms of codecs and so on, is exactly what we put in the SDP that we send in the SIP invite as well. And at the same time, whatever we receive from the SIP peer, we relay exactly as it is in terms of codecs to the SIP, to the browser at the same time, which means it's up to the browser and the SIP device on the other end, which may actually be a browser again, as I showed in these demos here. It's up to them to actually negotiate stuff. And if you need to do any kind of transcoding or codec adaptation, we typically leave it to other components, mostly because we tried as much as possible not to reinvent the wheel. So there are other softwares that are much better than us in doing live adaptation of codecs, especially for compatibility purposes and these kind of things. So all you need to do is involve one of these components on the SIP path, and that can take care of it for you. But we try not to do any transcoding because it would weigh down the resources of Janus. So you can handle a lot of calls this way without doing any transcoding. If we also did transcoding on ourselves, it would basically take more resources from Janus.
Okay, hope that answers the question. We have another one here from Artem. If NAP-PTR record configured for group of SIP servers, can Janus correctly make register call? Some SIP clients have problems with configuration of this scenario.
To be honest, I don't know. I don't think we ever tested that. So I should basically check if the Sophia SIP stack has some issues with that. So I should probably check. I don't have an answer for that. But in general, we try to we try to leave it up to the browser to basically do some resolution of the actual addresses to connect to and these kind of things, and this simplifies things. But we should have some functionality for that in the code, but I don't remember the status of that at the moment.
Okay, we have one more here. Is there a failover for the active call if one Janus gateway goes down?
No, if the Janus gateway goes down, it means that the peer connection dies as well. And so, I mean, it's something that if everything happens only at the SIP level, you can somehow take care of this. But with the WebRTC peer connection in place, it means that you also have a DTLS channel between the WebRTC browser or user and Janus itself for the peer connection part. So they created basically a DTLS channel to exchange all the cryptographic information. If that's the connection between that user and Janus dies at the same time, you cannot just move it to another Janus instance because they would not have the same cryptographic communication between them. So it's just for the same reason why you cannot just move a TLS connection from one point to another, or if you can, it's very, very hard, let's say. So for WebRTC purposes, if Janus dies, it means that the WebRTC peer connection dies, which means you need to create a new one. So one thing that we might do and that we have considered is actually, but this would actually not work if Janus dies. So only if the connectivity goes down for a little while. So basically, if Janus dies, it means that also the SIP endpoint that we created on behalf of that user is dead as well. And so we would need to create that again, which means that you need to basically register again on a separate instance and basically set up your calls from scratch.
Okay, I think that covers all of our questions. And you are right on time, my man. Let's get a round of applause for Lorenzo Miniero.
Thank you very much.
That was an awesome.
And let me say hello to Dan, who's coming after me. So I just wanted to say hello. And thanks guys again for having me here. I'll stop the presentation now and I'll leave the floor to Dan. Thank you very much.
Thanks again, Lorenzo. So that's right. He mentioned Dan Bogos. He's here with us. He's going to be talking to us about CGRateS integration tutorial with OpenSIPS. Dan, how are you?
Hi, I'm doing very well, and I'm very impressed about the event which you have put together. So congrats for that.
Well, thank you, man. We worked really hard for it, but you got to really commend the community because they're the ones that made it.
Yeah, impressive. So congrats again. And Lorenzo, very nice talk. So okay, so let me share my screen. I should just get into the point. I'm on time, correct?
You're on time. Go ahead and just present now.
So I prepared some slides to give a bit of overview of CGRateS and CGRateS with OpenSIPS integration, and also a bit of revealing of the secrets which we have put in master. Because, you know, starting of the year, sometimes in middle February, we have released our first stable branch. And ever since, we split the functionality by adding more and more in master. And this is why we also are more excited about that branch than about the stable one. So about us, for whoever doesn't know us, we are located in Germany, in Bavaria. Over 13 years of experience with architecture server-side solutions in VoIP. We did both wholesale as well as retail, and we kind of understand by now what means a real system outage. Now, the most important in my talk is CGRateS. What is CGRateS? It's a real-time enterprise billing suite. Real-time because it was designed to be real-time and online from the day one. Enterprise because it works more like a framework than a single software. Billing suite is because we have primary targeted billing, and nowadays we do a suite of softwares which are related to billing. There should be easy to get into an external infrastructure. Should be plug and play theoretically. It should be easy to accommodate in the future new components. So it's also non-intrusive into existing setups. So you don't have to route your traffic through a switch of our choice. We communicate with the switch itself. We exchange information with it. It's all open source. It was born sometimes in 2010. First sources were published in 2012. So quite some time ago. The full sources are available on GitHub repository. People are asking if we can provide some additional extra functionality. No, we don't do that. Everything is fully there and free as in beer, they say. We function with release branches. So we will maintain, we plan actually to maintain the release branches for the moment, at least indefinitely. So we are adding new functionality in master. And once we will get the release out, that one should stay stable and also get patches, because we realize that bringing patches into older versions should not be such a big effort, because we already know the code and it was written by us. So for the moment, we will officially maintain all the branches which we have in our code. Master is where the functionality comes in. If you want to leave like a bleeding edge, that's the place where things are happening. No add-ons in private repositories, as previously told. We have also a very big consideration for community contributions. It's a performance-oriented software. Our secret, I tell to everybody, so there should be no secret anymore. It's our advanced caching mechanism built by us. So this includes transactions, LRU, list record used. So we only keep the hot data into cache, and TTL records to auto expire if you have data which you want to be temporarily available into cache. Asynchronous processing with micro threads. This comes from the main language which we use, which is Go. We were one of the first projects written in Go. When we released in 2012, Go was in weekly release. Test-driven development since day one. We have over 7,000 tests as part of the test suite. This is why we can declare our master as stable. So we run master in production sites at our customer with support. So this is why we always say, if you want to go on a release branch, is your call. If you want to go on master, we support you there as well. Only don't bother us about the upgrades, because we are doing them and migrations in master, they are like from one day to another. Regarding our activity, you can see since 2012, mostly since here in 2013, when we started going to conferences. I think in 2013, We have also been to an OpenSIPS mini summit in Chicago. And since then, we are constantly pushing and we have commits, so you cannot find any month without activity. For example, this is the status in August. So we have about 102 commits in the GitHub. And also you can see this August, we have hit quite some records with 10,000 lines of code committed sometime, in I think July. And we are constantly maintaining and very active. Regarding functionality, it's a modular architecture, cloud ready. So it's built on top of microservices. We support Docker, we support virtual machines, we support also bare metal. So any kind of infrastructure suits you, it should also be suitable for CGRateS. All the communication is done via APIs. So even our components are talking between themselves over APIs. So you should be very easy if you need for some reason to hide some functionality. You can very easily replace one of our components with your own one. And as long as you follow the right APIs, or as long as you expose the right APIs out. Feature rich, we are what people are calling online charging system, or also offline charging system. We have multi-tenancy. We have real-time configuration reloads. We support our basic functionality was rating engine. We added to that derived charging, which means you can emulate or you can fork your events, your requests, any number of times, and you should be able to handle very well in this case particular situations like premium chargers versus local charges versus premium charges added to the same call, special VAT cases, for example, in US, where you are able to apply the VAT only at the end of the call due to all these particular fees which are applicable to per minute or per second and so on. So you can use this derived charging for adding your special VAT. Then you can use derived charging for calculating your real-time revenue in terms or winning in terms of price the cost which the supplier will charge you versus the cost which you will charge your customer with. It's also possible to make chains of distributors in this way, or resellers, and you can fork these events any number of times, and also in real time and with prepaid built-in. We also support a number rating, which is always a requirement here in Europe for wholesale. So you can bill based on where is the call coming from and the destination where the call is going. We support account balances and bundles. We have session or event charging with balance reservation and refunds. This is part of the online charging functionality. CDR logging with support for interim records and rating queues. These rating queues are important because it helps you integrating the CGRateS into your existing billing infrastructure with a minimum of fuss. So by putting the CGRateS with rating queues configured, you will get the CDRs, for example, from your OpenSIPS switch already rated. they will look like coming directly from the switch itself, because there are few milliseconds between OpenSIPS pushing the CDR via events and CGRateS delivering it towards you. So that's what rating queues are. Fraud detection with automatic mitigations. In former OpenSIP summits, I investigated this deeper. LCR with QoS or LCR over bundles. Call statistics with pattern monitoring. So you can build this call statistics or a high number of call statistics, even generic ones, for example, ASR, ACD, total call cost, total call duration, average call cost, average call duration, and even generic like sum of fields in your event, or average of fields in your event, or distinct fields. If, for example, there are some exotic cases in mobile worlds where the first 20 numbers which you dial in PSTN networks, they become your local or your home zone, and this will be non-chargeable numbers. Regarding agents, we support diameter, radius, DNS. DNS is still an interesting topic, because there are still switches doing LCR over enum, and practically they don't want to implement anything else but enum routing, or they don't do anything good except enum. SIP server with process templates we have recently added support for, but we only function as redirect SIP server, so we don't target being a full SIP proxy like OpenSIPS is. However, we work very nice in tandem in terms of SIP redirect server for OpenSIPS. Resource allocation controller. You can monitor channels, you can monitor CPSs per destination, per time, per customer, per supplier, per group of anything you like based on your events, because these resources are applicable to your events, and they have generic filters built in. API server with support for GOB, which is a particular serialization, binary serialization in Golang. API server for JSON over RPC and JSON over HTTP. We also support API server for WebSockets if anybody wants to use that still. We have built-in high availability, and we also have dynamic partitioning support for larger networks. You can split automatically between different RALs. RALs is the component which calculates the rating and also calculates manages your bundles. And we are pretty agile in developing new features. So we always have something on to do, and it never ends, to be honest. I always thought it will be easier, but after 10 years developing the same thing, I realized that we are not even at obviously at surface of it. So in order to understand better, we have made an architectural schema, a logical schema between the modules which we have. And for you to understand better what CGRateS is, I will explain you a bit what these modules are doing, so you know what you can enhance your network with. Here on the left side, we have the agents which are converting between outside world and CGRateS world, which starts with this component, which is sessions. This should be practically the gateway into CGRateS. Diameter for mobile, radius for even Wi-Fi authorization people are still using, or accounting still in use. HTTP agent to convert between REST and CGRateS APIs, DNS agent, as I told you, for enum, SIP agent as redirect server, asterisk agent for asterisk, free switch, Camaillio, all these open source components. And here, luckily, we don't have to maintain, because in OpenSIPS, there is a native module built in, which is talking directly to our session. So if we will put the OpenSIPS will serve here together with all the others, but it's outside of our software infrastructure. However, being native, it gives you the freedom of playing with CGRateS functionality directly into your own scripts, like having CGRateS built in your OpenSIPS server. Event reader service, it's a generic way of feeding events into CGRateS. For example, CSVs, JSON CDRs, XML CDRs, fixed width CDRs. We also have implemented partially a TAP format CDRs. So it's able to even SQL generically, so you can write your SQL templates here. We are plug and play into MySQL, Postgres, Microsoft SQL, SQLite, and through our driver. So all this will feed events into sessions. Sessions will, based on the templates or based on the logic implemented into all these modules, it will convert them into various types of steps into our logic. So you will be able to authorize your sessions, or init, update or terminate your session, or feed CDR in. You are also having some very powerful APIs available, where you can combine all the modules which are sitting behind into just one API. So if you are handling properly the flags inside, then you can access all these modules which sit behind. Now the connections, if you see the connections between the components, they are all RPC. So you can have these agent sessions and other modules sitting in the same process, or you can split them over different processes, which means processes on the same machine, or in your Docker, let's say, cloud, or other virtualization techniques. So you are free to do the scalability in the way you like it. So behind sessions, you will have RALs, which is the component which does rating accounting. This is where the costs will be generated, and this is also where the bundles will be updated. CDR server is a generic CDR server which can receive from sessions the CDRs, or you can even feed in the CDRs yourself, because as I told you, you can replace any component of ours with yours. Attributes will be a component which does the mediation in your events, so it can change the content of your events, so it can add information or replace information in real time. This is why it's important we have it, because it serves the same purpose as the CGRateS itself and architecture, so it will be able to work very fast at high speeds. Chargers will be the component which does the derived charging. Here you can configure the rules in how many CDRs or how many events you want to split your session. Resources, as I told you, is to control the number of channels and resources used. Routes, it's the component which does routing. And here we have also implemented the LCR. This routes is replacing the old LCR or supplier module in master code. Stats, it's building generic statistics. As you can see, stats, it's reached via multiple connections, so it can have access to your real-time events, starting with authorization. So if you want to make statistics for the number of authorizations or call initiations or call terminations or CDRs, stats has access to them. So stats will be informed when they happen into sessions. Thresholds is the component which we call it like our own NMS. So it can serve also very well as a fraud detector, and also it can do automatic mitigation. You can see that thresholds, it's reached by sessions also. So you can, for example, be aware when your customer has tried to authorize a call to a blacklisted number. So you can automatically shut down his account when it happens. So it doesn't even need to go into connection mode. So just in authorization stage, you can already kill and disable his account because you detect the fraud there. And threshold is also reached by other modules. So for example, when the RALs, when the account, the bundles are being updated, thresholds, it's notified and can react on those as well. Threshold is connected to CDRs, so it can also monitor the calls which you make by the time when they are finished. And resources are monitored by thresholds, so you can react on simultaneous channels for a destination, for example. And as soon as your customer hits, let's say 90% of his channels, you can inform him that he's getting to close to his limit, or if he's reaching 90% of his channels in the middle of the night, this is abnormal behavior, and you can again shut down his account because you know that this should not happen. And thresholds has also access to stats. So if ASR is too high or too low, thresholds can react and inform your supplier or your customer directly. And also when you top up an account, so if they top up too much, it's again unnormal, and you can again shut down the account because he put too much money, which is not many are doing this. Filters is a generic way of applying logic to events, matching logic to events, and all these components are connected to filters. So we filter in a centralized mode. So this gives us access to having, let's say, an homogeneous logic around our modules for past and future, because you will be, once you learn the logic of filters, then you can handle all the modules in one place. And dispatcher is the high availability solution. Scheduler is the component which does top-ups and maintains accounts and executes regularly. It's sort of a cron, but built in CGRateS, developed by us. Event exporter service, it's able to receive events from various components. For example, even sessions can directly export events. So you can shortcut modules and send events as raw outside if you want. And APR server, loader to load data, cache. So you can also manage cache. You will have APIs for it. It's like dealing with internal database of CGRateS. And then behind will stay two databases. So one is the DataDB, which is based on NoSQL, or internal. So we can also serve without any kind of databases. And StoreDB is made for logging. This is built on top of Mongo or MySQL Postgres. What's new in master compared to v010? The SIP agent, it's a transactional SIP endpoint, support for UDP, TCP, and TLS. It's programmable via processor templates and limited to 302 redirects. We said for now because we always leave the things for the future, but we decided that there is no way for us to do more than 302 redirects because SIP proxy is very complex. We know that. Applications, multi-layer call authorization. So you can, once the authorization comes in, you can control a number of different things. So for example, prepaid control, you can do, because you'll see we are also doing steer shaken. So steer authenticate, password, IP address authorization, and call parameters. So we can use all these things to authorize the call. Call routing, this is for supplier selection, call parameters per call leg. So we can apply call parameters for each individual leg, like returning back the max duration, steer initiate header, CLI, destination formatting, for example, for number portability, emergency services. So all this via SIP redirect, which is quite powerful. One request, and this it's also very important for performance. So you don't hit CGRateS twice; you only hit once. Steer shaken, it's a standard feature set. We are doing origination destination checks, configurable attestation level, authenticate and initiate support. We are interoperable with Chameleon OpenSIPS implementations. What's particular on our implementation is that you can do API-based steer shaken. So you can check your header for authorization, or you can generate a new header via in SIP initiate, so in steer initiate. So that would be a reason for adding steer shaken into your old implementation of switch. Routes is the new module, adding routing support with a large amount of routing strategies, weight, least cost, high cost, QoS, resource ascending, resource descending, load-based, bundles, duration-based patterns, and quite some things we have put inside there. And we have simultaneous routing profiles match with weight prioritization. On the roadmap is contact center routing, AI with routing strategies, and standard interface for interconnects. These are all planned for some future. Rates, this is replacing already the rating part. It's a single file for management, making use of dual layer filters. So you are more way more flexible in rating. We can do partial changes over APIs and files, and a common interface for CSV via loaders. We have implemented float arithmetics yet now by using decimals. So we kind of fix an architectural problem from beginning. We have new functionality also, minimum cost. Event exporter service is to export the events which you receive in CGRateS. As I told you, it's giving access to events within multiple components. It's all programmable, so you decide what fields are going where, using attributes for mediation on output, and it can towards a number of different exotic interfaces, like, for example, Kafka and S3 on Amazon and other AMQPs and stuff. On the V011 roadmap, we still have replacing the accounts part, schedulers, and action plans. We also, regarding IMS, we plan adding a PCRF inside CGRateS because it was a feature hunted by others. OpenSIPS integration, finally. Prior to OpenSIPS 2.3, it was made out of 3 different modules for authorization, for call disconnects coming from CGRateS side, and for CDRs, we were processing the CDRs out of DB Flat Store. Up after OpenSIPS 2.3, it's very plug and play and native. You have bidirectional communication within OpenSIPS with CGRateS. So we can also kill the calls from OpenSIPS directly when we, for example, we detect that the balance is finished, or we detect fraud. After OpenSIPS 2.4, we have integrated also this sessions component. So now it's very modern and we'd say the right way. So finally, we have reached our integration tutorial. So what I have prepared is an installation of OpenSIPS on Debian Buster. I just simply grabbed net install from Debian and installed OpenSIPS latest stable, I think 3.1, out of apt opensips.org. I have installed CGRateS, the nightly version, because as I told you, I like to be sure that we are compatible to the latest version of CGRateS in order to properly support it. And I have used Zoiper SIP client for version 5 directly from Zoiper. So I'll move now to another screen. If by the way you have any question regarding the slides, maybe we can make a short break for questions, interim questions, not to forget. Otherwise, I'll just start showing you a bit how OpenSIPS works together with CGRateS. Nobody for the moment. Okay, so I'll continue and then we'll come back on questions later. I noticed that there are some questions on YouTube, so we can handle those after. Okay. Let me just maybe directly share a full screen.
Hey, Dan, would you rather answer the questions on YouTube now, or is it better later?
Okay, I can do that too. Okay, let me see. So,
okay, so it says that you have 2 versions of docs, the latest,
yes,
which is visible, and master, which is invisible. Only master has extended info about configuring, but it's not full. Do you have other docs?
Normally it should be on read the docs, and it should be 2 versions, not must. I think latest should be the right one, and V010. So if you go on the read the docs on the somewhere on the left side, bottom left, there should be V010 and master. I can also show that to you.
Okay. Let me.
We have here latest. So 2 versions, latest and V010.
Okay.
Maybe master is something which we have played with and we left it. This is why it's invisible. We only saw the visible latest and V010.
Okay. Okay, then you can move to the demo and we'll
Okay,
check afterwards. Thank you.
sure. Thank you for helping me. Let me see. What am I presenting? Yeah, so if you see here, it's latest and V010, as I told you about. And we plan keeping it in this way. This is the reason why we kept up with still with the reader docs, even if they display this annoying commercial ads, because of the possibility of having different versions and directly mapping to GitHub. We tried GitHub pages, but unfortunately there you cannot easily maintain documentation for different branches. Good. So now let's go to the. So first I will let's go setting up. So when you start, after you have installed CGRateS, which by the way, since we were at read the docs, let's just go again on them. You have here the installation here, installation link. So you can use packages for Debian or install manual packages, because we provide a package archive for both nightly as well as the V010. And you can also have packages provided by us for Red Hat Fedora CentOS via our own Yum repository, or you can also grab the RPMs directly from the package server, or if you prefer building the sources yourself, you have here the details. It's quite simple actually to even build the packages yourself. We also, we didn't add it here, but we have since a while, we have used in the project already a hosted version of Docker images. So we are hosting at docker.cgrates.org also own images of both master as well as V010 there. So once you have installed, for example, I used exactly these commands. So you add the key, and then you just apt-get install CGRateS on your server, and that should do the step where I am now. Once you have done the installation of CGRateS, you can then go to post install. So you install Redis server. One of here I see already that we have still MySQL there, but it should be MariaDB if you are a fan of MySQL. Postgres, if you want to install Postgres as StoreDB, or MongoDB if you want to install, and we also provide the setup scripts for that. Once you have all this configured, you should use CGR migrator in order to enforce the existing version. So first, initialization of the versions. So this is what I did in the server I have here. And once I have this, I start CGRateS. For the moment, I'm starting it into console directly, so not into daemon mode, in order for you to see what's happening inside. You see all these warnings. They are coming from Golang built-in, so they are not written by us. It's just Golang is publishing them on std out, and that's because we are overloading the RPC objects And in order to communicate also in process, they only are used to use these objects for external RPCs, but we use them for internal in-process RPC. These are the messages which you see from us, and you will see for each engine you start its own identifier. You can also customize your identifier if you are running this in a cloud architecture. This is very useful because you can see each process individually, which throws the logs out. You will also see all the modules which are configured, and if there are actions done, you see here the scheduler will query some actions and will execute. Now I have started OpenSIPS. If you see, OpenSIPS is started with our own configuration. We provide you for this tutorial custom configuration, so you just start with it, and not much particular done. So I have started this with the script, which is built in our share folder. So once you have this installed, you go to share folder, then you go to tutorials, OpenSIPS, and here you have two folders, CGRateS and OpenSIPS. So in OpenSIPS, we will find the configuration of OpenSIPS, and these are just things which I'm aware that you are much better than I am with them. The most important or particular thing is that you need to load CGRateS module and configure the connection from OpenSIPS to CGRateS. This is done on a port 2014, which is bidirectional JSON, a non-standard way of doing JSON RPC. However, it works quite good, and we are happy with it. So we are able to act as client to OpenSIPS, and OpenSIPS can act as client to CGRateS. So both way will work. So once you configure this, by the way, when you install OpenSIPS, you only need to install two things. So when you do the apt-get install OpenSIPS, you will do and OpenSIPS CGRateS. I think that was the I took this information also from our tutorial. So if you go to tutorials, you can find this here. When you install OpenSIPS, it tells you OpenSIPS CGRateS module. So again, it's all running, and OpenSIPS has, if I want to make sure that OpenSIPS restarts and reaches CGRateS, and I can grab the information between CGRateS and so now when I'll do any kind of call, I'm able to see transparently what's happening behind. So I'll fire up my Zoiper client. First, I need to make sure that these accounts will register. Looks like they are getting issues with that. So OpenSIPs look like running. Maybe just try to put it down. Okay, so it looks like it didn't go down, so maybe it's hanging somewhere. That okay, and maybe the funny. I'll do a quick restart. So the server itself is trying to restart. I'll just, due to this virtualization, it could be that I messed up my installation somehow.
Okay, Dan, I am Vasilios. I hope you are good. Until the restart, could you please tell us what about your future plans?
Yeah, so as you saw there on the roadmap, we
Yes.
plan finishing all this replacement of RALs, schedulers, and action plans, and then there will be a new stable release out. Could be that once we are done with this, we start resurrecting the old CGR admin interface. But this is still a long shot because there are always coming more priorities in front of that, and always people with emergency cases and implementations are pressing us.
So when we should see the .11
Yeah,
appear long term?
Yeah, I hope in about 6 months, if let's say if the weather is helping. So there should be a lot of stormy weather to keep us inside.
Okay, great.
But we are also one because we also like to work with the new architecture and new filters for everything. So we also are pushing to go as soon as possible with the new architecture. So
Okay.
I'm back with the. Let me see if I can. No, of course. Tutorials, OpenSIPS, CGRateS. Okay, so now CGRateS has already started. Okay, so this is done. Now OpenSIPS. Okay. I see a problem. OpenSIPS. The listening interface was the wrong one. I cannot reach it. No. Good. Okay, so I think that was the problem. I have reinstalled CGRateS and it overwrote the address of where OpenSIPS was listening. So now I know. So you can see from time to time there are some synchronization coming from CGRateS to make sure that the sessions which CGRateS thinks he has are also in OpenSIPS. Otherwise, if they are still sessions for any reason, maybe OpenSIPS went down in between, or I don't know, it will kill them. Okay, so if I quickly dial an extension, the call is authorized. That's because I have already set up the accounts. Otherwise, the call would be not authorized. We can see that the call started. So it's running for a while. It's on remote hold because it's I'm running inside the same SIP client. We also see that the CGRateS asks OpenSIPS from CGRateS side, so that proves that two-way communications works fine. We also see OpenSIPS is informing about the active session. So this is why CGRateS does not kill our call, because it sees that it's for real active in OpenSIPS. Now I will shut it down. We also see this sync again working fine. And by the time of shutting down, OpenSIPS will tell CGRateS that the call was ended. It was also 43 seconds, and it will send a bunch of information. All this information and the activation of the modules inside CGRateS, which implies the logic, this is configurable from OpenSIPS side. So it tells that it builds stats, it processes thresholds, it will also release the resources. Also, this was part of the authorization, and I configured in only one place. And here is the data which is sent. But this data is fully configurable, so you can add any AVPs from OpenSIPS into your CDRs on CGRateS side. We also see that the CDR is being sent to CGRateS from OpenSIPS, and CGRateS informs that everything was fine. And if I connect to MySQL, I like to use this G, so it shows me nicely the CDR. We can see that the derived charging works fine. So we have two CDRs for this session, which I just did. You see 43 seconds. And we also see some information coming from, this was actually information sent by CGRateS in the authorizations section. So OpenSIPS is sending it back and feeding into CDRs. So we can use it as part of the billing process further. So we can send it to the billing or invoicing system upstream. And this even password, you can use password stored in CGRateS if you want to. So you have a centralized point for managing all of your data. You can also see the cost, and you can also see how this cost was calculated. This is very useful and user friendly. So for example, if you want to use something like JSON lint, I use it because it's very, not because it archives all the information, but because it's very easy for me to display this. So you can see what every single information, how much and where it was taken from, and from which account, and rating very deeply in each CDR. So if you have any kind of trouble with your customer, you can go and show him all this information there. So I'll prepare to conclude. If we go, I lost ngrep. So if we do a quick authorization again, and we stop here, we can see that as part of the authorization, we are getting this information with PayPal account and password and LCR profile used. And we also reserve a resource group, and we also know the maximum duration this call should take. So after this, OpenSIPS will kill the call. And also this is, of course, end CDR with 0 duration, because we only had an attempt, so it was not an authorized call. Now, we can talk like for days if you want, because there are a lot of cases which you can cover depending on your own business needs. I don't want to take too much of the time here. If you have some, I don't know, if we still have time for 1-2 questions.
Yeah, I think we can allocate like 5 minutes for the question if there are any questions. I mean, personally, all the time it's fascinating to see, from year to year the evolution of the CGRateS project, and how you try to cover all the time new interesting features, and the fact that let's say CGRateS is not necessarily, at least in my opinion, correct me if I'm wrong, it's not let's say bound to a specific how to say functionality, like in our case, let's say OpenSIPS, a SIP proxy, so whatever we do, it's SIP related, right? You have this flexibility to be a bit independent, and you can talk to different entities and perform different different actions, not necessarily which are, let's say, SIP related. I mean, you started with a billing, and now, wow, okay, you do also steer and shaken, for example, right? Without actually having any access to the SIP traffic. So
yes,
that's why I'm saying there's a lot of flexibility in your case to play on multiple fronts.
Yeah, but well, it's funny you say that, because I have the same feeling against OpenSIPS. I see it from year to year that it implements things that nobody thought that are still implementable in a so mature SIP solution. So I think it's the same mutual respect we have for each other. And regarding Steer Shaken, we wanted to make it API available, because we are an API server. So we said it's a good addition for the other switches out there which are not having access to the SIP stack. So you can implement it in external process and inject it into your SIP headers. So this was the whole idea behind it, because we have even thought about sending this via diameter in, so we can push it in the mobile network in the same way it's pushed in the SIP network. So it's that was the logic behind it.
Yeah, with all these protocols right now, you can do a lot of interfacing with different other components. So you can, as I said in the beginning, you can talk and fetch information and process and offer services you know, in different areas. And again, it's interesting to follow the evolution. It's like in most of the cases, we had Lorenzo Mangani talking in the beginning with Homer or SIPCapture, and in probably 99% of the cases when you say Homer or SIPCapture, everybody thinks about the capturing, but actually, you know, in the last years, actually, you ended up doing more than simple capturing. You know, you can do analytics, recording, and so on and so on. And that's exactly the same case also with the CGRateS. You know, starting from almost like a pure rating, right now you do a lot of cool things. And okay, that you mentioned, let's apply the same for ourselves, and say, yeah, okay, we started doing like some you know, simply passing traffic, and we ended up doing a lot of creative things. But I think at the end of the day, the most important is just to, you know, to evolve, you know, with the project.
And you know how we are building these features. We have access to very valuable data like CDRs and events in real time, calls monitoring in real time, and all the time we say, how can we enhance this information? What can we make better use of this information? Because we have also the freedom. You know, in SIP the things are quite standard, but in billing not. So this is why it enhances us with a lot of freedom of playing around.
Yeah, I mean, everybody knows in these days, you know, having access to information, that's the goal of everything. Then you can extract and sell it in whatever kind of shapes, you know, and you know.
That's the next level, Vasilios. Maybe we can talk about this. We want to sell the data now. What do we want to do?
Let me say, okay, I have data, so we can share everything if we like. But let me see another perspective how I see the battle. CGRateS and OpenSIPS. Okay, CGRateS has introduced a SIP interface. So Bogdan, just be careful. It's just I know it's just for redirect, but Bogdan, please be careful. And OpenSIPS has shown another module that has to do with rating. So Dan, you have to be careful.
Yeah. This to be our worries in world, but in reality we are a micro market here, and by saying that we compete to each other, it will never happen, because the real market out there, they are still doing this radius and SIP with maybe version 1 or whatever, and that's the real money, not by competing with edge, like bleeding edge technologies. So I think this is what helps us becoming creative, like learning from each other. So I don't see any competition here or battle.
Of course, and this is how open source community should work, and everything is there, and you have to use it properly and share all the information and get the knowledge. So that's the main point here. Then both guys have done a great job, and believe me, we have integrated both worlds great in our environment.
Thank you.
But just as a closure, because we are running out of time, short idea. A couple of days ago, I mean, definitely there is a lot of overlapping between, you know, different kind of projects in terms what we are doing. I mean, we start doing stuff that, let's say, typically it's a PBX. Then probably CGRateS is doing also in the capturing area. Maybe Homer is doing also in the CDR area stuff. And you know, it's inevitable that you cannot just sit in your own bubble. But at the end of the day, as a couple of days ago, Giovanni said, you know, different projects are when it comes to different, let's say, topics or functionalities, it's just to pick up which one is the best for certain feature, right? So again, it's great to have options, but in the same time, okay, this is good for eating breakfast, and this is good for eating lunch. In the same time, nobody said anything if you start mixing, if it's good for you.
Yes, and one more thing, I didn't see nobody saying that WhatsApp is a competitor of Facebook Messenger. So they are doing exactly the same thing, but nobody says they are competitors.
Well,
So,
okay. I mean, I'm not to judge. I'm not using Facebook, so
yeah.
hard to say.
But you're using WhatsApp?
Yeah,
Yeah.
just because I have to.
He was using Google Plus, but is now shut down.
Oh. Go to
Yeah.
Google Meet now.
Okay. Again, I think we are like 10 minutes over, and then again, it was as usual an interesting catch up with what happened in the last year with CGRateS. And thank you for doing that. But we still have one more workshop from Vlad Patrascu. He would show us things, because about DKFS. It's digital feature key feature. Digital key synchronization feature, and that's a quite, I wouldn't say corner feature, because it's supported only by a couple of phones, but in the same time, it's a very interesting one if you start, playing around in the application server and class 5 features, because basically what allows you to do is to synchronize things, centralize and synchronize things, feature settings between phones and the server. But I don't want to steal too much from Vlad. The idea is it's a really cool in terms of showing how things are working. So having this said, I will let Vlad to take over and show us a workshop on how this great feature works. So Vlad, it's all yours.
Hello everyone. Thanks for the
Thanks.
Introduction, Bogdan. Let me first try to share my screen. Just a second. So is it visible? Okay. So
Yes, it's fine.
sorry.
Everything looks good.
Okay. So in this workshop, we will be looking into the device feature key synchronization protocol with OpenSIPS 3.1. So as it is a workshop, I will start directly discussing over the document from Broadsoft, so no slides necessary. So this is a protocol developed by Broadsoft, but it is an open protocol, so a lot of hard phones, IP phones implemented. For the workshop today, I'll be using an E-Link, but I think that a lot of Cisco phones also supported, because Cisco bought Broadsoft in 2018. Okay, so this was first implemented for the BroadWorks platform provided by Broadsoft. So this is a class 5 like SIP software system. It provides PBX type of solutions. So what the protocol actually does, as Bogdan has said, it synchronizes features that you might want in such a PBX platform, like do not disturb or forwarding. And this is just at the level of application server and phone. So it does not touch anything regarding how do you implement these features, or how do you cache them or persist them. So the features covered by this are do not disturb, call forwarding always.
Vlad, can I interrupt a bit? Could you control scroll and zoom in a bit just so we can? Perfect. Thank you.
Oh, I don't see how you see it. Okay, so call forwarding always, call forwarding busy, and call forwarding no answer. So these are the only features supported as far by the protocol, but they are quite easy to extend in the future if some custom phone manufacturers want to control other features from their phones. So the whole idea here is that you can activate such a feature from a button on your SIP phone, or at the same time you can activate it by accessing a web portal in the platform. So when you activate it on in the web portal, the phone receives the same feature status, and when you activate it via a button on the phone, the application server is synchronized with the feature status. So this is based on the SIP events framework. So it's a basic presence, but not really presence. It only uses subscribe and notify, so no need to publish anything, because the presentities are also the watchers. So it extends the package as feature event in presence, and it uses XML bodies to convey the information exchange between the application server and the phone. The schema is a standard defined, but we only use a subset of features that BroadSoft decided to use. So let's take a quick look at some call flows. So if you can see this diagram clearly, when a SIP phone first boots up or registers, it sends a subscribe message to the application server in order to create the subscription. It's a basic subscribe without body, and just the expired time and the event that it subscribes to is relevant here. It receives 200 OK, and then the server immediately sends a notify back with all the features that are currently activated or assigned to that specific user in the application server. So it's a multi-part XML, as you can see here, with chunks of XML for each feature. Like do not disturb has one XML part. Call forwarding always has one XML part. Call forwarding busy has one XML part, and so on. So when the phone boots up, it already knows all the features that are configured and enabled for that user on the platform. Okay, so now the next scenario is when you update or change the status of a feature from the application server. So this happens when you, for example, dial a star code and you process to normal SIP routing that star code and interpret it as a do not disturb or forward or anything else. Or when you have a web portal, when you just click and activate your desired features. So in that case, the application server sends a notify to the SIP phone with only the status of the change feature. So not an entire snapshot, but only the delta, so to say. And the phone just accepts the set feature. The last call flow is when you want to change the feature from the phone. So when you, for example, press the do not disturb button, the phone sends a subscribe to renew the subscription, but also includes an XML body that corresponds only to that feature and the new status that it has set. And also the important part here is that the application server also responds back with a notify, where if that feature is permitted for that user, it sends back exactly the same status and configuration. So there is one thing to mention here, that the application server can also be configured in such a way that you are not allowed to use a feature. So that's different from disabled. So for example, if you have do not disturb disabled, it's one thing, but if you want to enable do not disturb and you're not allowed to do that, you not only get a notify back with that feature set to false, but that XML body is missing from the initial notify that describes what features you have set on the phone. So if maybe some questions that we can take at this point in time. So if the protocol is kind of clear for everyone, or can we move on?
Yeah, looks good.
Okay. So now let's look at how OpenSIPS implements this and how you can work with such data exchange between the phone and the SIP server. So we'll directly look into the presence DFKS module. So basically, the main point of interaction in the script with the status and value of the features is through two script routes that you can set custom script routes for the presence DFKS module. And in those script routes, you interact with the values in the XML body through the DFKS variable. So with this variable, you can declare features as assigned and not assigned if a user is not permitted to use that feature. You can read the URI of the present entity. You can see what feature you want to set or get. You can access the status. And some features like the call forwarding type of features have also have an extra value besides the status, which is the forward destination. And the call forwarding no answer feature has also a ring count. So how many times the phone rings before the call is considered not answered and goes to the forwarding destination. So actually, we'll look a bit more into how this can be used in script in the next part. So I'll not insist on that now. Now let's describe the setup that we will use for this demo. So basically, we have a SIP phone, a single SIP phone, but also a user can have multiple phones, and the synchronization is the same on the features have the same value on all the phones. And the important part here is the provisioning of. So let's consider that we are a PBX platform. So we have in the database some extra fields for each subscriber. So actually, those fields could be only extra fields for the subscriber table, but for the purpose of this example, we created a separate table. So we have the username, the domain, the URI of each of the forwarding types. So call forwarding always, busy, and no answer. The DND status and the ring count for the no answer type. So we use a codification here where if a feature is not assigned for a user, so that user does not have the permission to use that feature, we have a null value in the database. And if we have for example, in the DND case, 0 means disabled and 1 enabled. And for the the call forwarding URIs, we have an empty string if the value is not assigned to that user. Okay, so let's take a look into the OpenSIP script that enables such a scenario. Is the text clear enough? You can see it? Okay. So we have to load the presence DFKS module, the normal presence module, the base presence module. So actually, the DFKS uses the API from the presence module. So at the presence part, we just have to handle the presence like normally. So in this case, we don't even have publish, so it's we only have to use handle subscribe. And when a subscribe enters the OpenSIP server, the two types of routes can be triggered, as we have seen. Get route, where an initial subscribe from the phone wants to fetch all the available and the feature states from the SIP server, and a set route, when a button is pressed on the phone and the status of a feature is changed. So through these routes, we can actually implement our provisioning logic in our platform. So we can do the database updates and retrieve the status of the features and the permissions. So in the get route, let's start with the get route. So this is the initial subscribe from the phone and further refreshes. So we based on the feature type, so do not disturb, call forwarding always, and so on, we do a DB query where we just get the status of the feature. So for do not disturb, it's that the ND field. For the call forwarding is the URI fields of the destination of the forwarding. For each type of forwarding, we have the corresponding URI. And this is, of course, selected based on the username and domain. And if the query is successful and something is retrieved from the database, if the AVPDB query returns something, we have to look at the actual value to see if it's a null value. And if it's a null value, that means that the feature is not assigned. So we set the assigned field of the DFKS variable, and that just tells OpenSIPS that the notify response for that initial subscribe does not need to include the XML body for that feature. And this is the same for all the feature types. And if we have a value in the database for that feature, we just set the status of the feature with the status that we have fetched from the database. In the call forwarding types, we also include the forward destination. So besides setting the status, we also set the destination. Here we have the part that says that if the string in the URI field in the database is empty, we don't have the feature assigned for that user, and we just send him a disabled feature with the status set on disabled. Okay, so in the case of call forwarding no answer, besides the status and the forward to value in the XML body, we also have the ring count. So we also fetch that from the database. Okay, and for the set part, this route is triggered when we receive a subscribe from the phone with a changed status for a feature. And also when we want to initiate the feature change from on a web portal, when we want to set the feature through a web portal, we have to manually run a mi command. I think I have missed it when I was discussing about the implementation of OpenSIPS. So we also have the here the DFKS set feature mi command. So this is the same. It has to do the same thing as a notify with a change from the application server. So exactly as what happens when subscribe with a body that changes the status of the feature is received from the phone. So we have to also update in our provisioning database. So we have the status synchronized. And in the set route, let's go quickly through this. We just query the database to see the previous status. If we have a feature that is not assigned to the current user, we send the status of disabled. So you cannot assign features for yourself when you press the button on the phone if you don't have permission to do that. But if the route is triggered through the mi function, that means that the mi function was called from the application, the web portal. So maybe an administrator changes the feature for users. So in this case, we pass a parameter in the mi command, a parameter that is passed to the set route if the set route was triggered through mi. And in this case, we allow the update to happen. So the code is basically kind of similar for all the feature types, with the exception that we update other fields in the database. So that's kind of it for fuzzy in the script, or someone wants to be clarified or something. I'm looking at the chat.
So if I can make a question, Vlad. The most important fact that I can understand here is that you automatically recognize and parsing internally the XML part of the phone request, for example.
Yes. Yes.
And then you can do anything you want with the result that you receive from the OpenSIPS script. And in this example, you just write it to the database, or you can write it on an external database, do a REST post,
a REST query or anything you want. Yes.
Yeah.
Yes.
And anything you want. So yes, you are doing the hard work for us, and the rest remains to the user.
Yeah, so the user has the ability to implement its custom logic, and all the things, all the thing that this route does is it populates properly the XML response in the notify. So
that's great. That's great, and
XML
it's very, very, very easy to recognize and make it to work almost out of the box. And yes, it's modular, and it can fit in any setup, as I can see that.
Yes, and even if the feature changes, the variable is designed in such a way to be kind of flexible. So you just, as coding, you just add some arrays and stuff like that, and you obtain a different feature. But you have to treat the XML parsing appropriately for that feature. Okay, thanks for the question. And now let's get the demo started. So okay, first let's register the phone. Okay, so the phone is now registered, and this is the web portal configuration for the E-Link hard phone. As we have configured here at in the start, we don't have any feature enabled, and also we have the call forwarding always feature not permitted. So this is not assigned to us, to our user. So first, let's, you can also check here in this tab that all the features are disabled. So let's set a feature from the SIP phone with the SIP button. I'm gonna take the webcam and try to show you on the phone. Hope you can see it well enough. Okay, so can you kind of see the phone's display?
Yes, now.
Vlad, maybe you should stop the sharing when you show the phone, just to.
Yes, but I have to quickly jump back to showing something on the screen. So we go to.
Yeah, it's clear now.
Do not disturb. Yeah, it's the focus of the camera, and now, as you can see, the do not disturb is enabled. And let's look at here at the trace. So the initial subscribe, the notify has all the features as disabled, and search for that subscribe from the phone. Okay, so this is the subscribe with the do not disturb feature enabled, and OpenSIPS responds with notify that it accepts the new status. And if we look in the database, it has changed to 1. And yeah, if we do the same, now it's disabled. So that this corresponds to, let's find it. Oh yeah, this is subscribed from the phone with the confirmation. Okay, so let's now try to set the call forwarding always feature. So let's go to call forwarding, always forward, and enable it and put some random number in there. And as you can see here, practically nothing has changed, because also in the database, because the feature was not accepted, as we had that null field for that feature. So if we look at the subscribe, we can see that the phone wants to activate the feature, but the application server OpenSIPS does not accept it. Okay, so now let's set the call forwarding busy, so a feature that is accepted. Forwarding busy, enable sample number there, and now we see that that icon on the phone, and it's enabled. It also shows up in the database, and I'm just gonna put the camera back for 1 second. Okay. So this is subscribe with our number and through the activated status, and the notify that confirms it. And now let's try to better see how the phone synchronizes from the statuses that we have set by unregistering and registering back on the phone. So we just for the moment unregister and register again. And now in the trace, we should see the empty, not empty subscribe, the initial subscribe, and the notify from OpenSIPS with all the features as we had them before. So with the number, and I guess I think that was the only feature that we had enabled before re-registering the phone. Okay, so now let's see how we can update the status of a feature from MI. So this could be called from a web portal or anything else like that. So let's from MI disable now the call forwarding busy that we have enabled previously. So I have a command here. Call forwarding busy. And let me check if it's the right parameter. Okay, status and parameter. So the status should be set to 0, and the parameter is just to signify to the set route that it comes from MI. Oh, I guess I missed something. I'm not sure what was wrong there. Well, let's just try to set it with a new value. Okay. So now we should see the new 11888 number. In this case, we don't disable it, we just change the number. Let's also see on the phone that it has changed. Okay. Call forwarding. Busy forward. And here we have you can see the new number with 1188. I'm not sure how to hold this, but we can also see it more clearly if you want, if we want in the web interface of the phone. Okay, and the last thing that we will look at is how we can enable a feature also from MI with more than one value, and that was the case for call forwarding no answer, where we had the ring count. So just paste here. Sorry, the no answer type. The forward to, and also the ring count value. Now let's set it to 3. Oh, yeah. Okay, so if we now look in the interface, we also have the 1188 number for the no answer forward with I guess it's converted to seconds here, so 3 rings of 6 seconds each. It's 18. So I guess that's it. It's the same on the phone, so I guess it's no point in moving the camera around again to show it on the phone. So that's it for the scenarios I wanted to show you. If there are any questions or discussions regarding on this topic.
I don't know, Vlad, if you are going to share somehow your examples, maybe has interested someone has to try it or demo or something like that.
I can post it on GitHub, but they're also quite similar to.
It's pretty straightforward.
Yeah,
just for people may want to that will see the demo. It would be very easy for them to try it like you did it.
Yeah, but it's also there are also some pretty close examples on the blog regarding the DFKS. So
yes.
Basically, the kind of the same idea, but I've only improved a little bit on the permission part.
I agree.
But there were even during the conference, like last week, there were many people asking for the config files, during the the short demos.
This is the main reason I asked that, nothing more.
Yeah, so maybe we can do some overall policy in trying to to grab all the configs and place them somewhere. I mean, as Vlad says, the essence of the script, it's already on the blog post. But from my experience, for example, when trying to work with something else, I mean, I'm not talking about OpenSIPS. I mean, that's something like at least we dream it all the time. So, but when working with something else, it's very, very useful to get some, A to Z working example, like a config that, that, okay, I'm just putting it over there and boom, works, even if I don't understand it fully or I have to dissect it a bit just to so yeah, we maybe we should consider that.
Most of the times this helps a lot people that do not have the experience regarding the feature set or how to do the little things regarding the scripting part. And I always got valuable information from the example, so why not?
Yeah, and as Vlad said, how it works. I mean, this feature with you know, all the presence related parts. It's not necessarily an easy one to do or to understand or to control and so on. And actually, what we see here is just the tip of the iceberg. The 90% of the work, you know, it's a lot of code signaling on the presence and stuff like that. And
I got it in first place. That's I told Vlad before that it's one line. it's,
Yeah.
it's automated in one line. What else?
Yeah, you just do something like status equals 0, and that basically compiles the entire XML.
Yeah, I would say it's a quite, if I can say so, weird feature, because it's very, very well and rigid defined when it comes to the endpoint side. So on the SIP side towards the CPUAC, I mean, you have the XML format, you have all the presence, how it should work, and that's it. You know, you have to follow the specs. But on the same side, you have the you know, you have the other side for facing the application server, because you get, again, you centralize data coming from two sides, application server and user agent. So on the application server, it's exactly the opposite. I mean, basically, you cannot rely on anything because you know, you have in this simple case, okay, call forward and DND, but if you go to how to provision into a database, there is no standard way, and you can come up with at least 1,000 ways of doing it. So that's why I said, okay, let's do the script, and you can do whatever you want over there, because yeah, there is, again, there is no best practice in this area. So that's why I'm saying it's a bit weird. It's very rigid on one side, but very flexible on the other one.
Yeah, like in my example, I only use the empty strings to codify that the user doesn't have the permission to that, but it can also be ACLs or anything else, flags, or however you want to provision.
Yeah. Maybe it's not even part of, let's say, of the OpenSIPS ecosystem. Maybe it's completely somewhere else. You know, all this.
Just try to make up an example to.
Because this can be very, very easily implemented in a cloud-based infrastructure. You just send out to a broker or another cloud-based database, for example, and you just control it, and it's out of the OpenSIPS, and that's it. You don't do anything else.
Yeah,
it's pretty straightforward and open mind regarding the implementation. So it's a great feature and very nice implementation.
That was the reason why we did it. I mean, okay, first of all, we had some use for it, but in the same time, it's a kind of a feature that, logically speaking, it makes sense, and it's a pity that, okay, it's not getting standardized as a way of working, and in the same time, maybe something more generic. I mean, it's not only for the call forward and DND, and that was something that I was talking to Vlad when he did the design. I said, okay, let's make it a bit more general. So maybe in the future will be quite easy to add new features. So not only the one specified by Broadsoft. So I don't know, maybe at a point the phone will support more. But it's a nice idea. It's a quite cool how they thought about using presence for that. Of course, it's you know, let's say, forcing a bit the boundaries in terms of how the presence should work, but still acceptable. And again, it's a quite useful, in my opinion, and feature, because it's probably everybody using phones. You have this kind of a dilemma. Okay, what the heck do I do with the phone versus the setting on the server side? You know, you have to be careful just to keep only one status across all devices and your platform at the same time.
And the most important part is, for example, we have many requests for people that they have phones in their offices, and suddenly they lose connectivity, and they don't have telephones because, for example, they don't have any other way to make the call forwarding. So if they had it on their phone before, it should work out of the box. So yes, there's plenty of space here, and a very, very important feature.
There are plenty examples in this area, like okay, you have your phone, configured with all these features, and you have some current setting in terms of forwarding and DND, let's say the phone on your desk, and then you just spin an SIP client on your mobile device, and okay, you want to have the same kind of settings. You don't want to start over again configuring everything. Also, you just go home and quickly you need to work out with the phone over there. So then again, okay, do I need to provision it again, or so there are plenty examples where you need to actually to be able to share through the platform all the settings. I mean, the settings for all the features for your account.
And they are pretty common. It's pretty common. Most for us, it's about 80% of the times the forwardings stuff.
Yeah, I'm not sure how in other cases. I mean, in a non-BroadSoft environment, I mean, I wouldn't go so far to say the environment because, for example, Link it's supporting this, so it's already outside the BroadSoft bubble. What other alternatives I would say are for something like that? I mean, how other phones are trying to do it.
We have seen that feature in SNOM phones that we are using.
Yeah, correct.
Yeah,
So,
this one or something else like but similar.
It
the
is
feature.
called in the same manner, but to be honest, I've never used it.
I will try it. I will try it as soon as possible. So I will let you know if you haven't tested it on SNOM. So I will do it and give you the results.
Again, I was just curious because personally I don't have so much experience in the end device area, and I was, curious to see if there are other alternatives to this problem, so something else rather than DFKS.
Okay, understood.
But again, that's my pure personal curiosity. So let's not make a big fuss about it.
May not. I'm not aware of something right now.
Mm-hmm. Okay.
So it may be done, for example, SNOM has some features regarding posting a request for pressing buttons and setting things on and off. So this can trigger an application server remotely for changing the status of the phone. And you can both ways
But that's something else
reprovision.
than SIP. I mean, it's maybe HTTP or something like
Yeah,
this.
yeah.
Okay.
It's not a SIP based. That's why it's another way to do things, and you can reprovision the phone on the status using HTTP commands, URLs.
Gotcha. Mm-hmm. Okay. Well, so I'm not sure if there are any other questions for Vlad. Rezvan, are you on the YouTube channel? Just to double check there if there is anything there.
Yes, I am, but there are no further questions there.
I'm here.
Hey, hi Max.
Hi.
We haven't talked today.
Hi Max.
We have.
Yeah. Well, it's getting really late on this old side of the world. So probably people are already wrapping up. So probably we should do the same. Thank you very much, Vlad, for the presentation and for the really cool demo.
Thanks.
Yeah, being the end of the day, even most of the former, presenters are not here. I would just like to say thank you to sometimes just joking, we are just saying the Lorenzo brothers, to Lorenzo Mangani and to Lorenzo Miniero, for the presentation, also to Dan and to Vlad for showing a bit more than slides to us, because that was the purpose of today, to actually, let's say, put our hands a bit in the technical dirt, in the code, and make to see exactly how things are done. So some kind of a hands-on experience, if I may call it like this. So yeah, thank you to all presenters of this day. And to a certain point, we can conclude that the Open Summit 2020, at least the public side, is completed. Of course, we still have tomorrow a continuation of the Open SIPIT, right, Maxim? Tomorrow will be another session for the, let me remember, what was it? The push notification? No, the steer and shaken and...
Yeah, that's probably all we will do. After
Okay.
today, so we kind of learned that it takes quite longer than we expected. So even for simple things like this authentication, but yeah.
You know how it is, Max. Interoperability sucks. So you have to treat it carefully.
It's
Yeah,
nice to
so
do something about it.
will you post some kind of I'm not sure, like, I wouldn't say results, but some, I don't know, some outcome for in regards to the interops, or what's your plan on
Yeah,
that?
I hope so. I'm not sure what kind of format do you guys would like to see. So I will be open to any suggestions. Like
I don't know,
post
Ashchi will do it.
But yeah, with Livio done quite a lot of good work. Hopefully we moved a little bit further on better digest implementation. And we crashed few third-party products in the process.
Yes. Good job then. You know, it's when you... Sorry?
We crashed Giovanni too. Giovanni, you know Giovanni?
Yeah.
I think we crashed him.
Oh, okay. Well, yeah. Usually that's more or less the main purpose of such interrupt tests. I mean, not to crash, but to discover, the potential problems. Better discover them during the test rather than later, in production system or something like that, or when it's, let's say, too late or difficult to fix or to to troubleshoot.
Yeah, exactly. The other reason to do it is to get those better protocol changes implemented sooner rather than later. Because if we do nothing, like, nobody does nothing, right? Before we started doing this, you guys had it in plans, but it was like, yeah, maybe next year or something.
Yeah, maybe we can plan it more in advance and do something, bigger scale, or putting more, at least from our side, more effort into this.
Yeah, absolutely. Anyway, sorry. You guys are probably tired and want to finish.
Yeah, it's like 10 p.m. already over here. So again, thank you everyone for today's session. Again, Max, thanks for running the show, the technical part for us, and yeah, great job also on the Open SIPIT. So, and let's continue that part tomorrow, and we will also have to wrap up everything by doing the training. So that will be again yet another interesting day. Okay, guys, thanks for being here. have a good night, good afternoon, or whatever, depending on if you're on the right or the wrong side of the world. And yeah, okay, let's keep in touch.
See you guys.
Thank you,
Bye.
everyone.
Bye bye.
Bye bye.
Bye. Good night. Good night.